This conference will now be recorded. This conference will now be recorded.
Hello everyone, welcome to day 10 in our Google Cloud Platform Architect training. So yesterday we started looking into our container concepts, and to some extent we have got an understanding like how to create containers and how to uh, keep it in a centralized repository. One of the Docker registry or repo is GCR, is what we saw, and we pushed it also. And one big advantage which we saw was since we pushed it, we were able to also access it basically. So yesterday towards the end, all of you tried pulling it into your Cloud Shell and it worked nicely. So that was a good option. And the last step which we did in our demo was making this thing public. And by making it public, we were able to access it. Everybody were able to access it. So, and I also showed there was now better options of sharing those images very easily. So either make it private or public. So only that kind of a stuff was there. If you are part of the GCP project, you should be able to get it access. But if you were to share it outside, it's going to be a little difficult. So that's where uh, artifact registry comes into picture. So if I just go to my settings back, because anyway you are not going to use the image, I'm just going to make it as public. So it's made back as public. The visibility should be shown as public now. Now the option which we did all this time, so containerizing all those things, we were assuming the system is powerful enough. So the kind of containers which we created was very simplistic, 4 lines of configuration, very small stuffs. But there is a question. Uh, it will be by default private, Mangesh. I made it public for you people to access it from your Cloud Shell. By default, it is always private. So nothing will be public by default. So at least the GCR will not be public by default. It is private by default. So we relied heavily on Cloud Shell. If you remember, to do all the stuffs, we heavily relied on Cloud Shell. And in my own experience, I have seen where I have written little complex Docker files, and Cloud Shell was not uh, powerful enough to fulfill that requirement to build a container itself. It was timing out because it was taking a longer time to pull images from various images and build something. So it was taking time, and sometimes I have seen it times out easily. And the machine configuration was very important. And we know we cannot change the machine type of a Cloud Shell. What you get, at least previously, you at least I would say now it is better. So yesterday we saw it is E2 series standard. For some people it is E2 standard, E2. Some people it is E2 medium. So a decent configuration is what they have given. If it's a very long, bigger configuration, all those things, right? Docker configuration, your Cloud Shell will not come to your help. So is there any alternative? We need to look for that. So one of the alternative is we can use it. We can use our own laptop. But again, the problem with our own laptop is the network connectivity. Heavy images needs to be downloaded, so you should have a better network connectivity. And my own experience, I have a pretty decent laptop. So even in that, the moment I install Docker, it takes up a good amount of memory and CPU. So it's always better to use something which is provided from cloud itself. So Cloud Shell was for learning purpose, fine, but we should also know something which is done at a production level, right? So for that, what we will do is we will look into a new product which can do something very similar and also make our lives little better with a product called as Cloud Build. So this is a serverless CI/CD engine where if you have used Jenkins, to some extent it is very close to it, not to that great extent, but to some extent. So it can provide you various tools where you can build certain stuffs in a serverless manner, meaning you don't need to worry about provisioning servers, networks, all those things. You say, I want to build this, that's it. Google is going to provision you the resources and give you. So let's see that part. So because it's a new service altogether, definitely you have to go and check whether the service is turned on or not. And also from yesterday itself, we made it as a habit. Whenever you turn on a new service, make sure you go and look into the IAM. What is a new IAM service account? What is a new service account this API enables? So that way you keep a track. So now in your GCP project, you may have very few entries of your service account. By the time we finish everything, you'll see lots of service accounts. Just wanted to give you a picture of how many service accounts we are going to create it. So this is basically, it's going to have a set of build tools. One of the build tools which you are going to get in cloud build is a Docker build itself. So the advantage of cloud build here is it can club couple of steps. So this is again for people to become more smarter. Now, if you remember, we used to do Docker build first. Then to push it to GCR, we have to do Docker push. If step 2 and step 4 can be combined together, that's going to be awesome, right? Now you may ask, we are missing step 3, Mahesh. It's okay. If you have built it, if you have tested it, it's working locally, all good. Now, going forward, not much changes to your Docker file. You need to have keep multiple versions built up. Then just doing both the combining both the stuffs is going to be a good choice, right? And you're not relying on your local system anymore. You're relying on a cloud system, which gets provisioned on the fly when you do it and gets deprovisioned once the pipeline or the data, it's not pipeline actually, once the Docker build and push process is completed. So totally serverless. And one good feature of Cloud Build is they provide basically 120 minutes of build time free every day. This is a free quota which you get every day. So even when you use a paid service, you upgrade your account, you are working in for a corporate, there you are using Cloud Build. This thing even applies there. So you can get different machine types of your choice. Under this free trial quota, you get N1 standard one, virtual machine with one vCPU and 3.75 GB of RAM for free, 120 minutes free. So meaning 2 hours of build process. Yesterday we saw to build a Docker, it took 38 seconds, right? So that's a build time. Uh, and to push it also, it may take some time. So totally 120 minutes is free for us. And there are lots of build tool which cloud build provides. They usually called as cloud builders. So if you just go to this gcr.io cloud builders, if you do in your browser, you'll see a good number of build tools. Why don't you do this, folks? Let me just help you out. If I just go, I'll open it in an incognition window. It's a repo, yes, it's a repository. So for Maven repository, how? So Maven is going to be basically Java based repository. So here this is only going to be Docker based. That's it, Deepak. So if I just go to a private window where I have not logged into anything. So if I just go to google.com, you will see I have not even signed in. The reason why I'm showing is I'm not even signed in to show the images which is made available are public. So if I just go to gcr.io slash cloud hyphen builders, it automatically redirects me to something called as container registry. So just give a try, folks. Just type in the browser, nothing required, just type gcr.cloud builders, cloud hyphen builders if I'm not wrong. That's it. It's going to automatically redirect to you. And these are some of the build tools which is made available, provided to you free of cost. And you see container registry in action. So if I go little deeper, this is my project ID. This is my project ID. Cloud Builders is my project ID. If you remember the way we did our GCR, if you just go here, you see after GCR images, the one which comes is always your project ID. This is what it indicates. So it's a project ID which Google has shared publicly. So all this images are made with public. You see this visibility is public. Like how I shared you yesterday, it has been shared by Google. And these are maintained by Google. And one of the build tool is Docker. You have even gcloud command, slim version of gcloud command. Why slim? So if you want to keep the size of your this thing smaller, slim is going to help you. Similarly, you have few runtimes available like maven, npm for node, then maven for your java, go .NET, all the build tools are available. So you can easily use this for building your applications also. So this is what we are going to use, where specifically we are going to use Docker. So what we are going to do is we are going to use this command, and we are going to talk more about cloud build in our module 7, where we are going to talk about CI/CD process. So here, because I wanted to give you a small heads up that you can use some cloud-based systems to build your Docker file also. So you don't need to always rely on Cloud Shell, because in production, doing something in Cloud Shell is not something which is a good thing, right? It should be automated. So that's where Cloud Build comes very handy. So wanted to just give you once and highlight how we can do it. And build and push both are clubbed together if we use this command gcloud builds submit -t, where is that is for the tag, and you mention the stuff. So let me just show you that. But before I show you that, let's check whether Cloud Build API is enabled or not. If it's not enabled, enable it. And before enabling it, have a check at how many IAM roles you have from the various for the various service accounts, and see what's going to be the new one. Okay. So if I just close this, go to my IAM, and I'll open one more so that I don't get confused. So currently I see only these three, and if I enable this, we yesterday saw there are few more servers. One of the servers which we enabled yesterday was GCR. So there is a GCR container registry service agent which is created, which is Google managed. No need to modify, no need to touch anything. So just leave it, let it be there. That's going to be used on behalf of us to do the specific work from the infrastructure perspective. Just leave that. So now I can just check whether the API is enabled. Yesterday we have seen how to create an enable API from the command line. Today we'll see it from the UI. So go to libraries, search for Cloud Build, Cloud Build API. Everything in GCP is API driven. So it's not enabled. So continuously build, test, and deploy. Let me go ahead and enable it, and let's see what happens. The API is enabled, and if I now go to my IAM, this is an important one to note. The service account. Now you see it was previously 3. If I just remove this, it was 3 only. So the one which was Compute Engine default service account, which was enabled when we turned on the Compute Engine, and this was also created together. Now we have a fourth one, to that list, which is called as cloud build service account. This is the ID. Currently, if I'm not wrong, there are some, it usually creates one, which is by default this one. And we will use this service account heavily in our module 7, where we are going to do some CI/CD process. Give this service account more role. If I were to deploy something into a Kubernetes cluster or into a virtual machine, we'll give more access to this. Something like service account, user role, all those things. So a new entry is added when we enable the API. Now, how does this look? Basically, if you wanted to see it, go to your IAM. This is again part of the tools. So if you just go to your tools, the first option which you see is cloud build. Just click on this. API is enabled, so we should not have any issue. So this is the stuff. There's nothing currently, no history of any build, nothing. It's basically empty. Uh, so now what we will do is do the same process and see how we can do a build using cloud build. Okay, so and I'll also check what's there in my GCR, what's the latest version which we had, so that we'll push the next version. So if I just go inside this, we have pushed 1.0 is the version 20 hours ago. Now, so just give me a minute, folks, 1 minute. Sorry, folks. So what we'll do now is we'll use this command which we saw in our slide, gcloud build submit -t, the stuff. And we are going to have basically a newer version because already the version is there. So we'll see a newer version. And I like to also show what happens if you don't tag it also. This is also something important from the exam. So let's just go to that same location where we had our Docker file. So you have something like the Docker file, the server.js file, everything. What we'll do is we'll do gcloud. So you'll have gcloud builds submit -t gcr.io/dev shell underscore project ID slash if you give the same name, it's going to be a newer version. That's it. If you give the same name, my app, it's going to be new version with a new tag. But if you give something new, it's going to be totally a new image itself. Let's give it to be part of the same image itself, my app, but I'll call it as version 2.0. Version 2.0. Now let's see how fast it's going to do. And I also wanted to put time in front of it, so that we know the complete time to build it and to push it. Now, one important thing to note here is just to prove that this is not going to use cloud build, sorry, not going to use cloud shell. I'm going to put one more tab and show you the Docker images. So how many entries would you see, folks? If I just hit Docker images, how many entries you may see? I have not done any build. Yesterday we did some build, so today we wanted to see how many builds are going to be there, how many images are going to be there. Zero, folks. Zero. The reason is it's ephemeral. I never, after the class, I never went to the cloud shell. It's more than 24 hours, like it's almost 20 hours, if I would say. Uh, so I would have stopped it, session would have timed out. So I would have relaunched my cloud shell. So nothing is going to be there because cloud shell is ephemeral. So I wanted to emphasize this very much, folks. So when you start working, you may get more surprises, but please remember it is ephemeral. So it is not going to be there. So that is the one. I can also put a watch command to just to keep refreshing every 2 seconds. You see a clock is working. So every 2 seconds it's going to refresh. I don't want to run this command again and again. It's going to refresh it. So why I'm doing it, I just wanted to show you if I use cloud build, it does not even use any resource from your local instance where it is running. So this command is doing. So it's only the command, that's it. So entire build process is happening somewhere else in the cloud. Okay. So hope this part is clear, folks, what we are going to do. So yesterday we learned it doing it in our own cloud shell. But Cloud Shell will have its own limitations. The machine type is going to be small, and for our learning purpose is good. But in a long run, this is not going to work. You have to use some tools like Cloud Build or a virtual machine. Your good old friend virtual machine. You have to use it. So let me just hit enter, authorize it. Creating, there are some steps which is doing it, which it is doing, and you should be able to see a process starting here. History, in the history you should see a new process. It should show up. Not sure why it is not showing up. Global, it usually shows a entry. Let me see whether it shows the entry. Okay, done. In 31 seconds it is done, folks. The complete stuff is done. Let me go and see it. You see it here? Nothing is there. Nothing is there. The image will not be in your local system. Everything was done in cloud in 31 seconds. So this is my total build time. So if I just go, it should have shown me the screen. Uh, Let me just refresh it. It usually shows that history. Yeah, it shows now. It did not refresh actually. So actually in the cloud build, it only took 17 seconds. Much faster. Much faster. So to create it and also to push it, both was faster. The reason why to push it's going to be faster is because the entire process runs in a virtual machine which is provisioned uh, in a region which if you don't mention it, it's going to take one. If you mention it, you can it's going to take where the resource is very easily available. It's going to use that resource and provision it basically. Or you can also mention uh, in this region only my cloud build should start. So just do that. The resource is going to provision, and the total build time which you have used is uh, 17 seconds. Now if you go to your GCR, refresh it, you should see a newer version. That's it. So both the steps were combined. Build and push were combined together. So there's one question. Can I see we need to run this backend by activating? Can I see we need to run this command after activating the cloud build API? Yeah, you have to do it only after activating the API. If you don't activate the API, uh, the service itself is not enabled. Service itself is not enabled. So you have to enable it from that. Like how we did yesterday in the command line, I did it today in the UI. Just go to APIs and services, preferred way of doing it, and then turn on the service. Now cleared it, so it's turned, it's there. Good. Now once the image is there, how server.js, how it is getting used in this command? Beautiful question, Mangesh. So thing is that what we are doing is For this command to work, I'll remove time. We know how long it takes. For this command to work, so this command, if you put this, it understands in the current working directory, there is a Docker file. So there's a Docker file, and that too the name of the Docker file is Docker file, D capital F small. Only then it's going to work. So to make this very clear, I'll just Control C, put ls. For a minute, I'll just rename this file to something else. Docker file batch 6. Now if I do it, it is totally a different file. Now if I run this command, I'll just call it as 3.0 just for the thing, and let's see what happens. It is picking it. You see this, folks? What is the error? So unable to prepare the context, unable to evaluate the symbolic link in Docker. So currently there's nothing. It was not able to find a file like Docker file explicitly, and the build process failed. The build process failed totally. So if you go here, you should be able to also see 9 seconds you spent to do this, but the build process failed. So make sure you run this command in the directory where the Docker file is there. If the Docker file is there, from the Docker file, you know everything, what needs to be done. So that's how the connect is happening with your server.js. Hope that makes sense, Mangesh. So in the place where you have your Docker file, this is going to make it. So this is required. Now when you run it again, it's going to make it work basically. So this is how Cloud Build is going to make your job little faster. So little faster there. Now, one important thing from the exam perspective, we have been talking about tagging to some great extent, and we are really following a good practice of tagging it. Now, I wanted to show what happens if you don't tag it. Okay, so what happens if you don't tag it? I wanted to show, and there is an official material which says you should always use this kind of tagging. uh, you should never leave some image without tagging. So I'll show you that also. Can I say we don't need to do any change to Docker file? No, it depends on the requirement. Now, if usually what I have seen is Docker file is created once. That's it. Once it is created, you don't even modify it usually. It's one time. So in our case, we did not modify anything because we did not had any requirement. Now, if you say Node.js 12 was released 1 year back, I want a latest version of Node, then you have to definitely change your Docker file. For example, if I just search for Node.js, what's the latest version of Node.js? We can use that. If you are going to use that, definitely you have to change your file 15.9.0. Let me just change this, folks. So 15.9, this is the latest version. Maybe 1 day, 2 day back, it would be released. When it was released, I need to see into the documentation. So this is the latest version. Let's do this. Now in this, I'm definitely changing my Docker file. So it is totally basically, I mean to say whether to use step 4, use 4, whether to use 4-step versus cloud build. So what we are doing here is, Kumar, Docker build, plus, so something like this is something like this. Docker build, if I just use this. So it is like this. It's a combined command which we are doing with cloud build. Docker build and Docker push. If you combine both together, what you get is the command which we are trying now. So it's combined together. So if you use gcloud build, it's going to combine it together for you. So little faster, and it's also going to run not on your cloud shell local machine. It's going to run somewhere in the cloud. Hope does it make sense, Kumar? So hope that is clear. If it's not clear, please let me know. Yeah. So we have changed something to our Docker file. Let's try to build it. And now what I'm going to do is I'm not going to put a tag. And I wanted to show what happens if I don't tag it. Let me just do it like this. First time we are doing without a tag. Let's see what happens. So when I do this, you should see a new process here, folks. So for some reason, it's not refreshing. It's okay. Okay, refreshing. There's a new process started. New process started. Forget about the time, folks. It's in a different zone altogether. Build is running and we are creating a new image. Done. Is it success? Yes, it is successful. It is successful. To verify it, go and refresh it. Now, what do you expect when you refresh it, folks? A new entry? Anything else would you expect apart from that? We have not tagged it. If we have not tagged it, what is going to be the tag by default, folks? Any thoughts? What's going to be the default tag if you don't put any tag? We had discussed about it. Yes, it's going to be latest. This is the stuff. Now, as a best practice, you should avoid this latest option. This is not a good practice itself. It's not me saying. Let me show you official documentation. Okay, let me just show you this. This is from Kubernetes. When you are going to do towards the end, we will have all our containers are going to get landed in Kubernetes. So if you just look into this documentation, they very clearly mention caution. You should avoid latest tag when deploying containers in production, as it is harder to track which version of the image is running and more difficult to roll back to a working version. So always use something like this. We are already there. We are already learning a best practice for production. And this could be also a question in the exam, folks. Um, there could be various options, something on the best practice of containers. So if they mention somewhere like latest tag should be used, it is against the best practice. And this is from the official source. I'm not taking it from some medium post or from YouTube or anything. So it's kubernetes.io. This is the official page of Kubernetes, the open source version of Kubernetes. We have not talked about Kubernetes yet, but we will talk about that in today's class. So just wanted to mention this. I'm just going to put this in the documentation so that the cheat sheet, so that you are aware of this tip. So in our examination tip, and it's not only for the exam but also make sure, and I'll also put a link to that so that you know the official link. So this is an important one. Just to give you some more info, something on this latest tag I had got in my recertification. So I thought at least I'll share that info so you have this background. It's going to be helpful for you. So now let me show you what happens if I use latest continuously. So currently you see 3 entries. Let me go and do a build one more time. Now you see it became so easy for us. Otherwise it's going to be a little painful, right? Docker build, Docker push, all those things. Now one single command running so beautifully. So we are becoming smarter day by day in cloud. I'm doing my next build process. So the entry should be there in my cloud build. So as of today, if you see 17, 20, roughly around 60 seconds or 60 plus seconds, meaning 1 minute or 2 minutes is what I have used totally in cloud build, meaning 120 minus 2 minutes or 1 minute. I am still left with 118 plus minutes for today's quota. So and entire stuff which I have done so far is totally free. because it's falling under the part of this free quota. Whether you are a paid user or a free trial user does not matter. Google gives you free totally. So the build process is success. Now, if you refresh it, what do you expect, folks? Fourth image there. I am very much sure, you are also very much sure, you are going to have a fourth image. But what is going to happen? What is going to be the tag of that? Any thoughts? Is it going to be latest one, latest two, something like that, or something else, folks? New image we have built. What's going to happen? So what if it, can you have two tags, two images with the same tag? What's going to happen to the previous one then? So let's refresh it and see what's going to happen. Then you will understand the meaning what Kubernetes mentioned in their official page. So what's going to happen is uh, override. Yes, it's going to get overridden, and this one you will not have any tag. You see, it does not have any tag. The previous one, 5 minutes ago, which we built, it becomes without any tag. And sorry to use this word, it can become something like it's like an orphan image, so which does not have any tag. So it's going to become difficult for you to do it. So you have to either manually tag it old, something like this, you have to do it. Otherwise, if this latest image fails, how will you restore back? Will become difficult. And if you keep on using latest, it's going to always have issues. So hope this line which I shared you uh, in this official documentation makes sense, folks. Just wanted to wait here for a confirmation. So is this part clear? So avoid using latest. Avoid using latest part. So it's not a good practice. Prefer to use a version. And I would say if you're coming from the software development lifecycle stuff, uh, agile, all this kind of stuff, this version should be something what is there in your source code. Usually the developers create a new version. That version, this image version should be in sync. That's going to be the ultimate option, I would say. Okay, so now what we will do is I'll show you a page where this is not followed. Just a small fun fact, uh, the documentation is not from Google. Okay, the documentation is from Google, so it's from Kubernetes, which is going to be definitely leveraging the containers there. So the link which you tried before, what was that? gcr.io. Just to give a small fun fact, folks. So gcr.io, cloud build. This is also GCR only, where they have kept ready-made images for Docker, so many stuffs. Now let me just go into this. So dismiss Docker, and you will see the latest image pushed was 15 hours ago. 15 hours ago. Now, after some time, they have started using this one. Now you see here what they are using. You can have multiple tags. So from looking at this hyphen, what it indicates, folks, they are using latest. They were using latest uh, as the tag, and that's the reason these older images don't have any tags. So Google itself is not practicing that best practice in this case. Maybe if you want to write some email or something, do let try and check whether they can update all this thing. So but they may come back and say we are using this version there. So they are using two tags basically. So latest is one, which may have an impact. Now if this is buggy, they may revert back to a previous one which is only having the tag. So even if this is buggy, then you cannot revert back to the previous one, and you cannot even read this image. So complete image, if you were to see it, it's going to be something like this is how you have to restore. It's going to be little difficult to use this. You can use this complete one. This is also okay, but uh, nobody will know what is this version specifically. So you have to look back into the source, all those things. But if you are doing versioning properly, version 1, 1.1, 1.2, or 2.0, it's going to be a little easier. Okay, so that's the part which I wanted to share. I can close this. So that's on your cloud build stuff. So yesterday we started with my cloud shell. We came to your cloud shell. It was working. The images which we created was all working. Now what we will do is we'll do a demonstration where we'll try to run it on our good old friend virtual machines. A brand new virtual machine is what we are going to do. That is going to give us more exploration. Now we are slowly coming to that concept. When you containerize it, it's going to work in every environment, whether it is your and a local machine, my machine, AWS, Azure, or GCP. So this is the first step. Okay, so let's try to run the same container, or maybe a new container we can turn it on today, image, and try to use it in GCE, Google Compute Engine. Okay, so for that, what I'll do is I'll go back. I'm just going to delete these two things, folks. And when you're doing some implementation, right, it's good practice to write some cleanup steps where if you also see these all things take space, and we know GCR is based on the charge per GB. Per GB, $0.026 is what it costs. So you as a cloud architect should have something in the design document mentioned. If you are going to use containers, have a routine cleanup process. Currently, there's no built-in process to delete older images, and that was the reason why even in GCP itself, those various images which you saw, if I just go back, GCP GCR IO dot cloud hyphen builders. So if you just go there, even there they have not done a cleanup process. So if I just go to Docker itself, you will see images which has been built for ages. So you don't need images, these many images, you don't need it. So meaning Google itself has not used the best practice of cleaning up those images. Nobody is going to retrieve uh, a 2-year-old image and use it. So maximum, maybe the 2 or maximum within 5 backward images is what they are going to restore it. So as a practice, make sure you clean up your images continuously. So for which certain code has to be written. So there's no built-in capability. So you need to do it. So I'll just put this as a small implementation tip so that when you are designing it, make sure you do it. So uh, have a have a custom script to clean older, sorry, to delete older to delete older container image in GCR. Why should we delete, folks? Any reason why should we delete it? Is it because it is old we should delete it, or there's a specific reason to delete it? Yes, space, because it's going to take space, and if you have more, you are going to incur more cost basically, so that the storage cost can be reduced. So again, a cost optimization part is what you are showing as a cloud architect here. But you have to write a custom script. There's no built-in policy or something to say after 30 days, remove the stuff. Maybe in future it may come, but currently it is not there. Now, what we'll do is we'll create a new version, maybe 3.0. We know we should not use latest. 3.0 we will use it, which is basically a Node.js 15 version, the latest version as of the latest version 15.9, and see how we can deploy it on a virtual machine for the first time. So all these times we were doing it on a cloud shell, everybody's cloud shell. Let's try it on a virtual machine, folks. So for that, I'll go back to my Cloud Shell. I learned my mistake. I'm not going to leave it without tagging, so I'm going to call it as 3.0 because 2.0 is there already. So 1.0, 3.0. So, or if it was a small minor version, so you can do this something like this. So let's just build it. It's going to be super fast because it runs on cloud build. And from cloud build to pushing it to GCR is going to be easier because these are all same service. It's GCP services. It's going to be much faster there. And when it comes to the Docker process, if some images are already there, it's going to use that. There's a concept called as layering. If that layer is already there, it's not going to again pull it. It's going to be reusing those things. Done. It is successful. If I just go here, I'm not going to ask you a question now. If I just refresh it, I should have an entry with 2.v2.1 is what I would say. And it should show something like just now. Awesome. So we have our image built. This one was yesterday built. Uh, this one was again today built using a new procedure. And both these images, if you ask, are almost the same Node.js 12.14.1 version. But 2.1 version is a latest version of Node.js which we have used. And let's verify whether it's going to be there or not. Okay. So how do I deploy it? Simple. So if I click on this three dots, I get an option. Show pull command. We have explored it yesterday. Delete. We have explored it today. What is left over? The remaining three. For that, we don't know what is Cloud Run. We don't know what is GKE, but we know what is GCE, Google Compute Engine. Let's click on this. So if I click on deploy to Google Cloud, Google Compute Engine, it's going to take me to the Compute Engine screen. Even though we finished Compute Engine, so it's going to still again follow us like our IAM. So let's try to deploy it on a virtual machine. Now, when I do that, click deploy on Compute Engine, it comes to my Compute Engine screen with certain stuffs built in. It creates a label automatically saying that it's going to use something called as cost table, something we'll talk about that what is that in a second. Region and zone are going to be set because I have set it in my settings basically. Otherwise you can change it if you want. Then by default it's going to always use some specific machine type. If you want you can do leave it, or if you want to change it, change it. So I'll change it to something like this. Then the most important thing which we had skipped during our compute engine class was this container, which you see now is being checked. And when it is checked, you see this version. Now if you see this right, this way of tracking what version it is running is going to be easier rather than having a big chunk of string. So if I just go here, look at these two options. uh, if I just go to my GCR, my app. So if I just copy this full repository name, this is my, okay, this is the full repository name. If I just click on that, okay, this is my complete ID, folks. This is my ID. This is one way of referencing this image. The second way of referencing the image is basically this way. This is the second way of doing. So which one is going to be easier for you to track it? So if you use this versioning, this second option is going to be more easier for you to track it. So this was the whole thing which I wanted to explain with that tagging option basically. So it becomes so difficult if you just use something like this. I usually avoid this because it's difficult for me to know what image. very big number, and we cannot track it very easily. So when I do click deploy to compute engine, this checkbox gets enabled and it shows what image to be deployed on this virtual machine. That's what it indicates. Now let me just scroll down. Let me uncheck it for a minute. Meaning if you don't want any container, normal virtual machine. If you want to check it, it's going to show you that image basically. Now, is there any difference which you see when I check it, uncheck it, except that new text box coming? Is there any new difference which you see, folks? Checked, unchecked. Anything which you can find out as a difference, folks? Yes, Vivek. Yes, Kumar. So that was an important thing. So basically, yes, Anil B. So when you check a container image, your boot disk, the OS is going to be basically container optimized OS. So which please check with check you can use Docker image container setting is coming automatically. This is yes, when you click on this deploy from deploy on GCE, it's going to directly come to here and it's going to have the checkbox enabled. If you create a normal virtual machine, you have to do this yourself, because we tried to deploy it from our GCR Mangesh, so it directly gave us this option basically. So when I check this, right, what's going to happen is the boot disk. Okay, you want me to show it one more time? So let me just go back. Go to your GCR and please don't do the demo together. You will definitely lose track. So watch it and then do it later. So, but I can show you once. So go to your container. You click on this three dots. You have an option called as deploy to GCE. When I do it, it's directly going to come to my compute engine screen with that checkbox turned and with that specific image with the specific version. So it's going to come there. So if I click on restore, it's going to show me the options which I did. So this checkbox is going to be turned on. As most of you figure it out, the OS is going to be container optimized OS. So what is this container optimized OS? This is basically based on Chromium. Chromium, based on that, Google has built it. And one important thing is, because you are going to deploy a container on a virtual machine, for this to run, what is most important, folks? I'm going to deploy a container image on a virtual machine. What is the most important thing? OS, yes. A specific OS, yes. Apart from that, what is most important? Assuming the basic things are there. What is the most important thing to run a container image? Any thoughts, folks? What's the most important thing? Yes, Shripal. So you need to have a container runtime. Docker is important. Docker is important. So that is where you see it here. The kernel is Chromium. It is going to have Docker specific version. So having a Docker is very, very important here. Without a Docker runtime, container runtime. So I like the short form which Anil mentioned, CRT, container runtime. So without this, your container is not going to run. The container image is not going to get deployed. So you need to have this. And if you use this specific boot disk, Google is going to make your life simple where you don't need to do it. It's going to be built in there. That's what it very clearly mentions, but it is not the latest one. The latest one, if I'm not wrong, is 20 something. So this is slightly older version. And you get few other options. If you want, you can explore it. And this was one of my interview questions in a larger organization where they asked. And since was doing heavy things on Kubernetes, so it was so easy for me to answer. The question was, the interview question was, what's the popular OS which you use when you are containerizing stuffs or when you are running containerized apps in GCP? Costs, container optimized OS. So it was so simple to answer it there. So That's it, folks. What you wanted is uh, this checkbox now, which we did not explore in our compute engine class. We are now exploring it, and it by default gets this thing. Now if you say no, as per our organization policy, we cannot use container optimized OS due to some reason. You have your own business restriction. If they say we have to use always red hat specific version, then what should you do, folks? To run a container, you provision a normal Red Hat virtual machine, install manually Docker, and then go and run it. That's it. It's going to be a little extra work which you have to do. But if you go with sheer container optimized OS, it's going to be built in for you. And if you ask me, I would go with container optimized OS. The reason is this OS itself is optimized for running containers. So it's going to be much better compared to running it on your specific OS of your choice. Just a thought. And I was looking into some vulnerability reports, I guess 6 months back or so. There was a vulnerability reported. COS it's based on Chromium, Vijay. It's not Ubuntu. It's based on Chromium OS, not based on Ubuntu. So very clearly mentioned here. It's based on Chromium. Uh, So in one of those vulnerability report, I saw, COS stands for Container Optimized OS. So in one of the vulnerability reports which I saw was they had mentioned this was related to Kubernetes kind of a stuff. So there were where they mentioned if you are using Container Optimized OS, you don't need to do anything. It's already taken care. But if you are deployed something on Ubuntu, you have to do follow these steps. If you have deployed on something else, you have to follow these steps. So that gave me an good idea that if you are using container optimized OS, basically most of the patching Google does it for us. If you do something on Ubuntu, Red Hat or something, you have to do it yourself. So with respect to containers, so it's a good option to use basically. And for us, we don't want to install Docker. We are not interested in installing, fixing the dependencies, all those things. So better go with container optimized OS. In short, it's going to be called as COS. That's it. So that's it, folks. Just clicked on that. We came. That's it. We are not going to do anything. Just click on create. So click on create. Let's wait for the VM to come up. And you will see some real fun facts here once it comes up. Yes, it has come up. Let me just SSH into it. Real fun facts once we log in. The OS is container optimized, and the container which you are going to run is Alpine. Let's see what and all happens. So let's see the Docker is there. It should be there definitely as per this thing. So 19 version is there. Now let me do Docker process. Ours is not running. Let me see one more time. Ours is not running. So it's taking time for it to get. So our image is still not there, folks. So let's wait here. I have put watch command. So it's going to refresh the screen every 2 seconds. So you see our new image came. So usually it's going to take little time for that image to be deployed. So you have to be little patient there. So our entry is showing. All good. So this has been running. Now what I will do is show you a real fun thing where your concept becomes much clear with container. Sorry, let me increase the font of this one, folks. Size large. Okay, make it as largest. So what's the OS? To know the OS, you can use this command. Always look at the pretty name, which is going to show container optimized OS from Google. And we know the Docker is running there. That's good. What could be the version of Node.js on this host operating system, folks? Any guess? What could be the version of Node.js running? Any guess? 15? Okay. Anything else? 12? Okay. So that's what we saw. So we are just guessing. There's no harm in it. So how do I check the version? I just use this command. And for your surprise, Node is not even running. So on my host operating system, which is container optimized OS, will not have these stuffs built in for you. So it's not there in my host operating system. Now let me log in to my Docker instance. So the name is this one. This is the ID. Now what I will do is do docker execute interactively. We learned how to do this, right? And because we are using Alpine, the mode in which I can log in is always sh mode, not bash mode. If I just go here, the prompt changes from a dollar to a hash. The reason is because I'm a root user in my container. Now if I put ls, I see the content. Now the most important fun fact, node hyphen hyphen version. What's going to be the thing? It's going to be what you mentioned in your Docker file, 15.9. Yes, Anil. So what you mentioned, the latest version, you're going to see it. So this is a true concept of container. So where the host operating system does not need to have the runtime which you want, or the software or the dependency which you want. If it's there in your container, it's all going to be good. That's it. Now what's the OS? Let's just check it. etc OS release, it's going to be Alpine. So the host operating system is container optimized OS. There's no node version, but when I log into my container or connect to my container, uh, a specific version of node is there and the OS is Alpine. So does this make sense, folks, about how do you manage dependencies, all those things? Meaning you can have multiple containers with multiple versions. Now I can have one more, which is going to be version 12 version of node as a container. It's going to work. So it's not going to have any issue when it comes to dependencies or version compatibility. So you cannot usually on your laptop, right? You can usually install one virtual machine only. Sorry, one node version only. If you want to install multiple node versions, multiple Python versions, you have to do some extra works. But here you're going to get your own namespace and you are going to leverage it. So hope this part is clear, folks. Now the last part, containers running, that's fine. Have you tested it? It is really giving the response or not? We need to check that part, right? So for that, let me see whether this curl command works. Curl command localhost 8080. It is working. Awesome. It is working. The container is running. Now, can I give you access to this output? Because the one which runs in my cloud shell, I cannot give you. The image is still private. We made it private, so the image is still private. But can I give you access to this? Welcome to containerization. Access to this. How do I do it? As a web-based application. So to do that, very simple. We use our virtual machine concept. So this virtual machine can be accessed by you via an external IP address. So the only thing which I have to do for you people to access it is make sure I have a firewall rule which is open to port 8080. That's it. If you just do that, you should also be able to access it. So slightly a jump to networking, but for a short time only. So what I will do is I'll just create a firewall rule. We'll talk more about how to create firewall rules in our networking class, module 5. But for now, I have to open this. Without opening it, you will not be able to access it. So let me just open it. So how do I do it? And if you don't understand this step, it's okay, because we are going to do in detail in our networking class. So go to networking, firewalls. There are already some built-in firewall rules. I'm not going to modify that. I'm just going to create quickly a new firewall rule called as allow my container. Just a small example. And don't worry about the settings. I'm just going to leave most of the stuffs default. I want this to be applied to all my instances in this current network. Anybody can access it from the world, basically, is what I'm saying. And anybody is little risky, but what is the port which you wanted to expose? The port which I wanted to expose is only 8080, nothing else. Only port 8080, web based. I can access it from anywhere from the world is what I'm creating. That's it. If you have not got it, no worries. We will do it in detail in our networking class. There is a firewall which we created. So 8080. Now what's the stuff which we need to do it? Simple. Go to the virtual machine's external IP address. Try it whether it's going to work. So copy this. Awesome. It's working. So from nowhere, we have come to a virtual machine level, folks. That's awesome, right? So I guess you can also check it. It's going to work at your side also. It should be working. So to some great extent, my wish list of running my 7 lines of code in GCP has come true. Has come true. That's a good option. That's a good option. Hope till here the concept is clear, folks. Till here the concept is clear. Any questions on this? Till here what we have done? Okay, it's clear. Now, everything working fine. So I'm just going to delete my VM. So afterwards, I'm just going to say you something. Okay. What is the difference if we use Ubuntu compared to Chromium? Is the OS faster than Ubuntu than other OS? It is optimized for containers. So it is optimized for running containers. That's first thing. The second thing is if you use Ubuntu. So for example, if I use Ubuntu, some OS comes with Docker. Some OS does not come. So if I choose Ubuntu, for example, go to my boot disk, Vijay. So if I go to my boot disk, Ubuntu, uh, you take the stable version or the latest version, depending on your choice. You choose one and install it. Provision this. What may happen is this version may not have Docker runtime itself. First of all, you have to install Docker runtime. That's one thing. Maybe you may have other components which may be impacting the performance of this build process. So that's the only difference which I would say. It's up to you again to use what image you want. But if you don't want to get into those management part or the operations work of it, I would say going with container optimized OS is going to be better, because it's been built for that purpose. It's a purposely built OS. So if you want Ubuntu, you have to make sure these steps are followed. Or maybe you can create an image, a golden image where Ubuntu is there, specific version of Ubuntu, specific version of no Docker. You use that for every stuffs which you are going to build on, which you want to build on a virtual machine. That's the difference. Fastness may be there, but I have never compared. There's no benchmarking for me to share it basically. So Chromium OS built-in Docker runtime. Yes, that is a key part. So let me just delete my VM. So that we'll go to the next part. In the Docker PS output, we were seeing two images, but we did build one. Okay, it was not two images which we did. So okay, what one was ours, but there are other some components which is going to be created automatically, some other Docker images like stack driver logging, all those things. So few other system related processes get started. That was a good observation. Let me just assess it and show you that. Oh, we already have it. So if I just do here Docker process, you will see stack driver logging. So this is for logging purpose and all. So this gets turned on by default when you use container optimized OS. We'll talk about stack driver at a later point of time. Awesome. So let's just stop this. Go back to our slides. Now, the next slide is where we are getting into Kubernetes kind of concepts. Now we have seen stuffs on virtual machine itself and the pending stuff which was on virtual machine. The container stuff is also now clear. Now, just for a minute, you show this part. Now, if you show this entire process of containerization, the concept, all those things to the organization who is totally new to this stuff, what they will say, you show this, it runs in my shell, cloud shell, your cloud shell, it runs in virtual machine, all those things. That popular dialogue of saying that it works in my system, it does not work in your system, I don't know, that is going to be totally removed. So that's a good one. Now if you show these kind of capability to them, right, what they will say basically, what will the organization or the business will say, folks? What is going to be the response from them? You have been into this thing, wow, awesome. um, Followed by that there's going to be something there. So I use this phrase, you are the victim of your own success. Yes, Anil, you are the victim. It's like you showed a very cool feature, now you showed a successful thing, now you are the victim of that. So meaning what the business will say, wow, let's do everything containerized, let's containerize everything in our which is our workload. That's going to be the stuff. So one container running it on a virtual machine was so easy. It is like if you take an example, like there's a birthday party, uh, and it's a kid's birthday party, and if it's one kid, two kid, manageable. But if you invite the neighbors, relatives, all those things, and around 20, 25 kids are there in the house, it becomes so difficult to manage them. And that's one usual reason why usually kids' birthday party, you will have a magician or someone who's going to attract their stuff's attention and keep them in a controlled manner. So you need to have some kind of a teacher or an orchestrator. Similarly, if you come here, if you have one container, you don't need anything. Basically, a virtual machine is good enough. But if you have multiple containers, it's going to become difficult to manage it, configure it, make sure they are in the right state, how they should communicate. All those things, it becomes difficult. All those things becomes very difficult because business has asked for it. So we showed the concept. Now the business says front end, middle tier, database also you can containerize it, folks. That's an advanced concept, we will talk about it if required. So everything containerize it, meaning lots of containers. If there are lots of containers, it becomes difficult to manage them. So to do all those things, that's where we have a orchestrator, one of the popular orchestrator, which is called as Kubernetes. So this is why we are looking into Kubernetes. So it took us a day or more than a day, or like more than a day session to understand why Kubernetes. So lots of containers. If only one container, I would say no need of Kubernetes. So a virtual machine is good enough. But if you have more containers, then is where the value of Kubernetes comes into picture. More on what is Kubernetes, all those things. We at least know why Kubernetes exists now. More on Kubernetes after taking a 10 minutes break, folks. So let's take a break, come back, and then look into Kubernetes, the history. A little bit of history is also important. And then we'll start looking into the features, then we'll try to deploy it on a GKE instance. And we'll see what is the difference between Kubernetes and what is the difference between GKE. All those things we'll try to see it. Okay. So take a 10 minutes break. Once you're back, we should do our next part. So stop the recording.
This conference will now be recorded.
So before the break, we understood the importance. How do you deploy it, and how do you make a container accessible to the external world is what we have seen, like as an app. We saw that, and we also saw uh, why a product like Kubernetes came into existence. More containers, so meaning you need to do some kind of an orchestration. So you can you can just do a small analogy to the orchestrator. So if it's this music fest where there's going to be an orchestrator with a small handy stick kind of a stuff, where he's going to say when a drum should start working, when a piano should start doing, or when a trumpet should start doing. So it's the same stuff there. Which service should communicate at what time, when it should scale up, all those things is going to be done by this Kubernetes. And it's industry leading, the most popular open source container orchestration service which you get as of today. So there's also few other orchestration tools. Docker itself has it one called as Docker Swan, but they stopped much support there. They themselves realized that it's not going to be a good one to compete against Kubernetes, because they have containers. So if they can have a container system, why don't have a orchestration system for that? They had something, they still have it, but not much uh, enhancements they are doing is what I heard. Docker Swan. um, Kubernetes is very popular, and just for your information, it was open sourced by Google. So it is a Google product. They open source this to the community in 2014. So you can see some connect here, folks. So it's like looking into some history part. So in 2013, Docker became very popular. That's where people started looking into containers. So lots of containers. So they started exploring it. But when they started using lots of containers, that's where the problem came of managing them. So in 2014, Google open sourced Kubernetes. So now the adoption became very popular. So because they have a problem statement managing lots of containers, this product came into picture as a rescue. That was awesome, using which they were able to scale, deploy multiple containers, manage everything. And the beauty of this was it was open source. So no vendor lock-in, no license restriction, anything. So just go to github.com/Kubernetes. You can get a latest version and provision it on the infra of your choice. 2014. Uh, and Kubernetes also supports two kinds of configuration, basically declarative and imperative configuration. So what does this declarative and imperative configuration mean? We are going to do a demonstration on that. Maybe one we should be doing it today if I'm not wrong. Declarative we may do it next class. So basically one is, if you want to do something, provision something, you run a specific command. Something like you want a virtual machine, you just do gcloud compute instances create blah blah blah. That's basically, I want this, I'm just going to run a command, that's it. So this is basically an imperative way. So by doing this kind of a stuff, right, nothing is going to be tracked. Basically you just mention I want to provision it, you just do it. But another beautiful option which you get is declarative. So meaning you describe what is your end state. I want, say for example, 10 instances of such containers running. It should have this much of CPU memory. So you express your end result, desired state. Kubernetes is going to get it for you, and it's always going to keep the state at any cost. So it's going to keep that state for a longer time there. So preserving the state is going to happen there. So that's basically your declarative configuration. So, and one big advantage of declarative option is you do everything via a configuration file, either in JSON or in YAML, yet another markup language, or JavaScript object notation. So two formats you can do it. So there's going to be some kind of a configuration. So when you think of a configuration, always this kind of a desired state, right? It's going to be good to keep it in a repository, a source repository, so that you can keep the track changes which you do. Maybe today you wanted a version 1 of an image to be deployed. So you do that changes, check in or commit the code, the configuration into the repository, cloud source, source repository. GCP also has a product called as cloud source repository. So everything can be easily tracked there. So that's declarative. So you mention what's your desired state, Google is going to achieve it, or Kubernetes is going to make it achieve that. Imperative is you directly send a command, create me this, delete me this, that's it. uh, and if somebody wants to do the same thing again, they have to just use the same command, so no track or nothing is going to be there. So usually power users use imperative, and it's preferred as a best practice to use always declarative configuration in Kubernetes. We'll see all those things. So this is basically what is Kubernetes in a nutshell, folks. An orchestrator, uh, an orchestrator comes only if you need multiple containers, meaning if you're just a piano player, you just play piano and you don't need an orchestrator for it. But if you have a troupe who does play a drum, a trumpet, a flute, piano, a violin, a combination, then only you need an orchestrator. It is the same thing. If you have one container, orchestrator is not required. But if you have multiple containers, when should one communicate with what, how they should scale, all those things. In that case only, you need Kubernetes, an orchestrator like Kubernetes. And since it's open source, you don't have any restriction. You can deploy it on your laptop also. So there's a miniature version of this called as Minikube. You can install it on your laptop. Low-end machines also it works. If you have a, a strong, powerful machine, you can install it on a data center in your data centers also. So 2013, Docker became popular. People went behind containerization. In 2014, Kubernetes became open source. It became very popular. They started adapting and they started using the Kubernetes for orchestration purpose. Awesome. But there was one biggest drawback of Kubernetes. It is like the Hadoop world. So when Hadoop started, right, it became very popular. But one of the big drawbacks of was setting up a Hadoop cluster. So it was like a nightmare to set up a Hadoop cluster. Same thing was happening to Kubernetes also. So in 2014, when they open sourced it to the open source community, the adoption was good, but there are very few people who can master this, provision it without uh, uh, any difficulty. So limited people. So provisioning the Kubernetes class instance itself was becoming difficult. So that's where what Google did was, it is anyway their own baby. So in 2015, they launched a managed version of it. They launched a managed version of it. So you don't need to worry about provisioning, managing it, all those things. The infra, basically, Google is going to do it for you. You just click a button, it's going to create a cluster, a Kubernetes instance, and you then focus on your container deployment, managing it, all those things. So that's the difference between Kubernetes. In short, they usually call it as K8S. The reason is between K and S, there are 8 letters. That's a simple thing. So Kubernetes and GKE, Google Kubernetes Engine. So 2013, Docker became popular. 2014, Kubernetes became open source and it became adoption became very high. And in a year, Google realized that it's not becoming so easy for everybody to provision it. Let's launch a managed version of it. So in 2015, they launched it and it became a hit. And just a small word here I wanted to use here. Everybody knows the first cloud vendor, the popular cloud vendor is AWS, market share wise, everything. So they were first in what? They're first in virtual machines. Everybody accepts that. And what was the first cloud provider who launched Kubernetes service, container as a service? It is Google. AWS started in 2018, if I'm not wrong, 2018 or after 2015, 100% sure. So the first cloud provider who provided containerization concept to the world was GCP. Nobody talks about this. They only saw say GCP, AWS is number one in few things only. GCP is also number one in few things. It could be number three in few other things. So instead of saying playing with the number game, I would say better choose the right product for the specific stuff. That way you are going to go with a multi-cloud stuff. The future is going to be multi-cloud. A hybrid multi-cloud is what I would say. So when it comes to containers, definitely GCP has a place there to compete basically. So a managed version of Kubernetes is called as GKE. Similarly, a managed version of Kubernetes in AWS is called as Elastic Kubernetes Service. A managed version of Kubernetes in Azure is called as AKS, Azure Kubernetes Service. So GKE and Kubernetes has a difference. Uh, so this is managed basically. So you don't need to worry, you don't need to know the internal workings of how the cluster going to get provision, all those things. You just go click on a button or use a gcloud command or use a rest api. It's just going to provision you, start using it. That's it. uh, there was a small information which I wanted to share here. Previously it was not called as in 2015 when they launched, they did not name it as Google Kubernetes Engine. They had named it as Google Container Engine, uh, somewhat close to GCE name only. Maybe because of that they changed it to Google Kubernetes Engine. Don't know what is the reason. Later they changed it, I guess in 2018 or 17, if I'm not wrong. In that time period they renamed it. So if you look into some older articles, and if you see something like Container Engine, it is nothing but your Kubernetes engine. And who knows, uh, if there's one question in the question bank and they have not even updated it, unfortunately that question comes to you during the exam and you look at a name called as Container Engine. It is nothing but your Kubernetes engine. Just make a map there. Okay, so it's just something like how Marketplace was previously called as Cloud Launcher. Knowing the older name is always going to be helpful, uh, at least if you look into some older articles basically. So with Kubernetes, it's going to be so easy to provision. I have seen, um, you can provision a Kubernetes. It's basically a cluster, groups of virtual machines. You can provision just in less than 5 minutes, and we'll see that demo also. So it's going to be provisioned in less than 5 minutes. So this provisioning is not a great deal, folks. Like if it's faster, if it's slower. So it may not be a deciding factor for an organization, but for a learner like us, this fastness is going to be always helpful. So because it's going to test our patience. So if I create something and I'm just in a learning mode, if it comes up faster with a success, it's good. At least if it's failed, it should show us immediately. So that's going to be really a good thing. So per my understanding, uh, among all the three popular cloud providers, Google provisions GKE faster. The Kubernetes instance which gets provision in Google is going to be faster. Uh, that's the fastest one is my understanding. And there are a few articles also, unofficial articles, you can look into it. It's going to be faster there. I've heard maybe now it should be improved. I don't want to mention the cloud provider name, but was looking into some article, again unofficial one, where it was mentioned like one of the cloud provider, not GCP, the other two, it takes 17 minutes to provision a Kubernetes cluster. 17 minutes. So maybe they should have improved it now. Not sure, but it's going to be a little longer in other cloud provider. And also because it's their own baby, right? They provide better. It's going to be a different experience itself in GCP when it comes to GKE and GCP. So that combination is really an awesome combination, and faster response, more support, more latest version support, all those things can be easily provided by GCP. So that's the difference, folks, between Kubernetes and GKE. Let me just stop here. So uh, hope the journey is clear. So from bare metal to virtual machines to containers, containers running on a virtual machine, then to maintain more containers, we came to Kubernetes, and that was becoming problem because provisioning the Kubernetes cluster itself was difficult. So we came to Kubernetes GKE. So today only we are coming to the main topic. What is GKE? Any questions on this, folks? Till now, is this clear? Not clear. So why GKE should be now clear. If somebody just talks Kubernetes, what they're talking is the open source version of Kubernetes. Only when they say GKE, then it's going to be Google's. So please make this as a habit and don't use Kubernetes as a vague word, because If they just mention Kubernetes, it's going to be on, it's an open source version of it. So you should always position it as GKE, basically. Any questions on this, folks? With the real world Kubernetes setup in an organization, do the employees working on setup have individual account to access Kubernetes, or it is a single account? So usually you will have something called as RBAC rules in Kubernetes. If it's an on-prem where they're going to give access, it's going to be again a concept of service account, Aman. So it's going to be a concept of service account, Kubernetes service account concept. They use something called as RBAC rules, resource-based access. So that's how they are going to use it. In GCP, we are going to leverage IAM, Cloud IAM, to a great extent to give access to stuffs. And in Kubernetes, you have a concept, slightly an jump, something called as namespaces. So you can use the concept of namespace and allocate a specific namespace to a specific business unit. That is also possible. Usually in on-prem, they provision a very powerful cluster. They create namespaces, one namespace for R&D team, one namespace for some project, another namespace. That is how they usually do it in real world, Aman. Any other questions, folks? Okay, if there's no question, a little bit, let's explore the architecture, the internals of Kubernetes, and I'll also highlight what is going to be focused going forward. So we now know what is Kubernetes, what is GKE. Why don't we look into this architecture? Slightly a busy slide. This was just taken from this URL, which is mentioned in the bottom. So from the official source only. The architecture wise, it's a cluster, groups of virtual machines. So where you're going to have something like a master, which is usually called as control plane, and some worker nodes, basically a master worker node kind of a concept only. So where you are going to have some nodes. Nodes are nothing but virtual machines in our GCP terms, GCE. So master worker node basically is what you're going to have. So you need to have at least one worker node for your deployment to happen. So there are lots of components in the control plane. The most important thing is an API server. So this is the bridge uh, which is going to do all the stuffs. All the heavy lifting stuffs is going to be done by this API server. And when we create a Kubernetes cluster, we will also be able to see the API server endpoint, the IP address. So this is the heart, I would say, of your Kubernetes. And there are a few other components like ETCD, which is a name, a key value pair, basically a store, persistent store, a key value pair which you keep it to keep all the details of Kubernetes. And you have some scheduler, you have some control manager and cloud control manager. Specifically, if it's on cloud, this component is going to come. If you're deploying Kubernetes on on-prem, it's only these four components going to come into picture. This is your control plane, basically, the master. The master. Uh, the container which you create, right, actually gets deployed not in the control plane, but in this nodes via virtual machines. So each virtual machines will have three components. It has to have a container runtime. That's a mandatory thing. Docker. So container runtime should be there. The second component which you should have is something called as kubelet. So this is a small agent which runs in those nodes, which makes sure your containers run as expected. So, and this also maintains the communication with your API server. So this is an agent which runs in every node. And the last component which you have something is called as kube proxy. Kube proxy, which is basically for handling all the networking part. So you have a kube proxy, kubelet, and API server. These are the most important components. Remaining is not important for us. And this is the architecture. And what I would usually do is I would not even worry about my control plane. This X is not to worry. It is not required. Don't worry about the control plane. Why? Because when it comes to cloud providers like GCP, AWS, Azure also does the same thing if I'm not wrong. You don't need to focus on the control plane. And the most important thing is yes, it is managed. It is managed. So basically, if you ask me, it's a 4 node. One is a master, 3 worker nodes. Literally, it is this one. So if I do something in GCP, I should expect to see 4 virtual machines, but you will not see 4 virtual machines. What you will see in GCP Compute Engine screen is only 3 virtual machines. The reason is the master is managed by Google. Yes, Vijay and Anil, that's correct. It's going to be managed by Google, and you cannot even see it, folks. So if I cannot see it, what is a big deal in me looking into the further architecture of it? It's going to be managed by Google. So I'm not going to worry about that. My worry is all about how many nodes should I have. So groups of this nodes, 3 nodes, right? It is going to be called as a node pool, a pool of nodes. So I'll be worried about what kind of configuration I should use for this node pool. So going forward, don't worry about the control plane. It's going to be managed by Google. I can just show you one small instance of how this is getting managed by Google. So GKE master or control plane is fully managed. So here, this is a screenshot, real implementation which I was doing. I did some change basically. So the change was something like this. So there were 3 nodes. Each of these nodes was having N1 standard 1 configuration. Basically, one vCPU, 3.75 GB of RAM. Now, there was a requirement for me to start little need more compute capacity, so I had to change it. So when I change it, the master also needs to be upgraded because more resource, more capacity, more resource can be done. So the master should be also strong enough, right? So it's like if there's a class where there's only 10 children's, maybe a junior teacher is going to be good enough. But if there's a class with 25 students, you need to have a little experienced teacher to manage them. So experience wise, the capacity wise, the same thing. So if your node pool capacity changes, anything changes, the master gets automatically upgraded. So this is a screenshot which I had, just wanted to share. So the master or the control plane is fully managed by Google, and you cannot even see it. I heard there are possibilities now. At least you can see the logs of those this thing in GCP, but you cannot see the node, the master node basically. So it's fully managed by Google. So let's not even worry about it. Let's worry about what's going to be going inside this node, the node pools, the pools of node. So that should be our focus. So Kubernetes nodes. So what's going to be inside the node? So we know container is going to be there, container runtime. That's what you see here, Docker. And I'm going to have kubelet, which is an agent, kube proxy for my networking. And the next most important thing which you are going to see inside your node is something called as pod. So this is the place where your container gets provision. Inside a pod is where your container gets provision. I can give a very simple example. You can treat your pod as a lightweight virtual machine. It's going to be something like a virtual machine. The reason is this circles which you see, these are all pods, folks. A pod will have an IP address. A pod will have a storage, memory, CPU, all those things allocated. More like VM only, right? So you get a complete stuff there, and inside that, there's going to be only one process which is going to be running. The main important process is your container. So the place where your container gets deployed is inside a pod. Now a pod can have one container, or it can have a container and a storage, a dedicated storage, or it can have 2 containers, one, or a combination of it. But basically a pod should have an IP address, and it should have at least one container running there. Now you will see going forward, the best option which people always prefer is either this option. Let me get my highlighter. Either this is a better one, or this is better one. Either one of them is going to be really helpful. Um, we will do this one. We will do this one. This is what we are going to do in our class, meaning one container in one pod. So this one we will not be doing in this class, but the one which is going to be helpful for this is something called as Istio, where you are going to have some proxy, sidecar proxy, all those things. We'll not talk about that. That's not part of the thing. But you can have multiple containers in the same pod running, basically. So why we would prefer this option is, in the beginning, we are just learning for the first time. So let's make it very simple. Let's not make it too complex. That's one thing. And the second thing is easy. What is one container? It is one application or one microservice, a front-end microservice, a back-end microservice, a middle tier microservice. Now, if I put everything in one pod, and if I were to only change my front-end microservice, this entire pod will have to go down. So instead of that, we will prefer to use this one. So each pod is one microservice. So that way, if I were to upgrade my backend, I just only upgrade my backend stuff. Now front end and my middle tier is still working fine. So I'm moving into a from a monolithic architecture into a microservice based architecture. Containers and microservices go hand in hand. You have packaged everything. What you have packaged is one service. Maybe if it's an e-commerce website, you log in. So authentication is one microservice. After you have authenticated, you will go and see some shopping cart. So it's a cart microservice. And you want to add an item to a cart and do a payment. Payment is going to be one microservice. Then uh, when you do the payment, it's going to definitely call some backend system and do it. So you will have multiple microservices basically there. So when you have these microservices, right, n number of microservices, managing these microservices, how one microservice communicates with another microservice, uh, how it should, if one microservice is down, what should it do? All those things, service, it's going to be a service management there. So that's where Istio comes into picture. It's a service mesh, basically, Anil Kumar, which is going to manage. If you have one, two, three services is okay. But if you have thousands of microservices, and if you were to manage all those things, that's where a service mesh is going to be required. That's where Istio comes into picture. So uh, that's the part. So it's going to be an advanced topic. We'll not talk about it, but it's basically a service mesh. So only if you have, again, if you have 5 microservices, I would say Istio not required. It's going to be an overhead for you. But if you have 20 plus microservices and you don't know how to manage all this microservice, what microservice should call with what microservice, when it should, if it fails, what it should do, all those things, then Istio comes into picture. So, and sometimes you may see people using the term pod and container interchangeably. Why they use that interchangeably is in this kind of a case. So if it is like this, basically there's a pod, there's only a container. Sorry, totally opposite symbols. So here there's only one pod, there's only one container in the pod. So sometimes they use this word pod and container interchangeably. So that's an indication that there's only one container running in that pod, basically. So if it's you can have multiple, you can have multiple, but in our case we are not going to look into that. So because usually the max which I would say is this one would be a better one. So where one is your main pod, the other one is something called as sidecar proxy, so which is in usually discussed in Istio concepts. So the container resides inside the pod. Yes, so this resides inside the pod. So you can treat something like this node, as a hotel, as a hotel, 5 star, 3 star, whatever it is you want to this thing. Each pod, right? Each pod, these days you have pod style hotels. You would have heard of it. So where for travelers is going to be easy there, and you are going to get it at a lesser, cheaper price there. So you get a pod, meaning just only place to sleep. That's it. Stretch your legs and sleep. That's it. So that's going to be your pod. And if you see, you get two styles of pods. For a couples, you get one kind of a pod, and if you're an individual, you get one kind of a pod. So that's a small analogy there. So a pod to sleep, and the container is going to be treated as an individual there. So is it possible feature? Is that a possible feature? Give me some demo about service mesh. I'm very much service mesh is out of topic, Vijay. So if time permits, I will try to do that. But it's not something which is important, because if you look into this thing, the exam stuff, they don't talk about Anthos. They don't talk about service mesh. So it's not there. So if time permits, let's try to do at least a slides or something. I'll try to show you part, but it's actually out of topic. So that's your pod. So that's what is going to be focused towards. So, and our focus should be always on uh, the nodes, the pools of nodes which you are going to create, basically. Now let's look into some terminologies. There are some terminologies which we have used. So as a small recap, container, the smallest unit of packaging your components to run. Pod is where your actual container resides or deployed. So this is the house or the place where your container resides. Node is your virtual machine. Simple. Cluster is pool of your compute engine, pools of compute engine. So with a control plane where you will not get access to it, basically. So uh, a control plane plus pools of node or node pool, basically, is going to be a cluster, Kubernetes cluster. So usually when you speak to somebody, uh, you should never say the word I'll provision a Kubernetes instance. That's not a good way, because you should say I'm going to provision a Kubernetes cluster. So I started using as instance because we did not use a term. Now we know what is a Kubernetes architecture. It's going to be basically groups of virtual machines there. So you should always use the term provision a Kubernetes cluster. So which is going to have a control plane and basically node pools of node. Now what we'll do is enough of lecture. What we'll do is we'll go and provision a Kubernetes cluster and do these series of demos. And we will do the same demo 3 times, folks. 3 times. The first time is going to be using UI to just make you comfortable. The second thing is going to be using command line, and in command line itself, two different styles, imperative and declarative, both the options. So totally the same demo 3 times we are going to do. You may get a little bored, but all the 3 options are going to be interesting. That's the only reason I wanted to do the same demo 3 times, basically. Um, so for this, if you see, the steps which we should do basically are package your app into a Docker image. Done. We already did it yesterday. So run the container locally and test it whether it is running fine. Done. Upload the container or push the container to GCR. Already done. Awesome. Out of 8, we have already done 3. The next part is create a Kubernetes cluster, GKE cluster. Then go and do the remaining stuff. So we have not done this part. So what we will do now is, anyway, the cluster creation is going to take around 5 minutes. So we'll simply create a plain, simple cluster. The explanation, I'll go and give you the explanation later. We'll just click on a cluster and finish it, so that when we come back from the break, our cluster should be ready, and we'll go into the explanation of each and every field in the Kubernetes cluster creation page. Then we'll go with step 5. Okay, so for now, let me just go to Kubernetes and just simply create it. Now, before going and creating a Kubernetes cluster, what should you do, folks? Before you create a cluster, what should you do? Any thoughts, folks? Yes. Enable, you are there, folks. Anil Kumar, you are there. Enable what? Yes, enable the API. Enable the API. Enable GKE. If you are enabling GKE, is nothing but enabling GKE API. So if I enable API, again a new service account is going to be created. Same pattern. So same pattern. One last time I'm going to focus it. Going forward, if we enable any new service, I'm not going to go into that details again. Enable this and see the stuff. So this one last time. So let's enable this. So go to IAM and let's verify, is there anything on Kubernetes? And I don't know why Firebase came. So it's usually used with mobile. I don't know the stuff why that came, but let's ignore that. So we know compute engine service agent, we know container registry service agent. These are the stuffs which is there. Now let me go to my Kubernetes API. Uh, Kubernetes engine. It's not there. It's not there. So let's enable it. This should create definitely one service account more. So let's enable this. All right, the API is enabled. Now, if I go to my IAM, you'll see one more account, which we saw yesterday, something related to Kubernetes service agent, something like that. So it's again managed by Google, so you will not see anything. So, but if I check this, you see a new entry, folks. You see a new entry. You see two entries, if I'm not wrong. How many masters will be available? We'll talk about that after we come back, Vijay. So depending on if it's a zone, it's going to be one. If it's a regional, it's going to be three. So depending on whether you create a zonal Kubernetes cluster or a regional Kubernetes cluster, it changes. Zonal is one, master is three, the default. So I'll show you that details once we come back. So service account, a new service account is created. And there's also something extra created, if I'm not wrong. This one, oh, this one was for the previous one, if I'm not wrong. Maybe a new one has created. Okay, good. So there's a new service account which is created, folks. Just wanted to mention that. Now let me just go and create a Kubernetes cluster. I'm just going to do simple Kubernetes cluster. We will explain. I'll explain you the entire stuff once we come back from the break. So create a cluster. And I'm just going to leave everything default. I'm not going to touch anything, and I show you the simplicity there. So just give it as batch 6 GKE cluster. That's it. So you have zonal or regional. This is what Vijay was asking. If I go with zonal, everything is in one zone, meaning I'm going to have one master only. If I go with regional, I'm going to have across three zones. So I'm going to have three masters. The control plane is going to be three. So regional is going to be preferred if it's a production. Since we are doing a small demonstration first time, so let's go with zonal. And I'm going to choose a specific zone as usual. The Singapore region should be good enough. Zonal, if you use in production, you will have issues. We'll talk about the issues with at a later point of time. So no, so if you are upgrading a versions, all those things, you will not have a master for some time. So it's not recommended to use zonal in production. High availability will not be there. We'll talk more on that. So I'm going to use a specific zone, which is Singapore A zone. That's it. Nothing else. I'm going to leave everything as default, and we'll talk more. So this is the default version. This is a default version. Okay. and I'll go with a stable version. I'll talk what is all those things. So I'll talk what is this all about. So what we did, just gave a name, then a specific version of Kubernetes, that too from a stable. What is this channel? I'll explain it. And I'm going to go with something which is stable version. That's it. Just click on create. It's going to take around 5 minutes for it to provision. By that time, we can take a break and come back, and then we'll explore more on this. So about the latency, all those things, Aman, we'll talk once we come back. We'll talk more about that. So talking about the latency right away in the beginning is going to be an overkill, I would say. When should you use regional? When should you use zonal? Everything we'll discuss it once we come back. So let the cluster get provisioned. So what we will do is, let me stop the recording here.
This conference will now be recorded.
So before the break, we actually took exactly 10 minutes break. Before the break, we just clicked on create button. I just saw in the middle actually, 5 minutes itself, the cluster was created. So, and we'll see a real demo where we will do it from command line also. You will see it's going to be less than 5 minutes only, usually. So it's pretty fast when it comes to creating the stuffs, uh, resources in GCP. So that at least gives us a uh, pace to learn things little faster. So the cluster is ready now. Because the cluster is ready, right, and we did not go through any screen explanation what are the various fields. Now we'll go through it, but we'll not provision that cluster, but we'll look into the various features. So by going through it, it's going to answer some of the questions which you have about the latency, all those things. All right, let me click on create cluster. We are going to do one more time. This time we are going to go with the explanation. Okay, so the first part and the foremost thing is you give a name. Again, the name of the cluster is going to be permanent. You cannot change it. So if you want to change it, you need to create a new cluster. So GKE Kubernetes cluster 1. This is this thing. The next is based on the location. You can go with either zonal or regional. What's going to be the difference? Price wise, performance wise, what and all going to be the difference? Let's look into it. First of all, when you make it as zonal, everything is in one data center. So one data center, there's a chance that it can have some issues, like it can be a downtime. It could be the zone is down due to a natural calamity, a hurricane, anything of that sort. So there's a chance that a zone can go down. So meaning you will definitely have low SLA, something like 3 nines only you will have if you're going with a uh, zonal Kubernetes cluster. From the availability perspective, it's not recommended to use this in production. That's the first thing from the SLA. So let me show you the SLA part. GKE SLA, service level agreement. Sorry, some wrong search. So if I just go to Kubernetes SLA, service level agreement for the availability or the uptime. So if it's a zonal Kubernetes cluster, it's 2.5 nines, 99.9. It's not 3 nines also, it's 2.5 nines. When it comes to regional, it is 3.5 nines, 99.95. For folks, if this is totally new, I would strongly suggest to look into the small website, because when you talk to enterprise architects, right, they will always use this term. Even in the beginning, for me, it was very difficult. This is a small website. You can go to Wikipedia also. You'll come to know what do you mean by an SLA of 99.5% of uptime is. If I just do this, so daily you can have a downtime of 7 minutes. Weekly 50 minutes, yearly 1 day 19 hours you can have down. Nobody is going to ask you why, because that is the SLA for uptime. So meaning 7 minutes you can be down for any maintenance stuff. So is this okay for you, for your customer? Then no problem, go with zonal Kubernetes cluster. uh, If you want little higher, so 99.95, meaning what's going to be the stuff? 99.95 of SLA. Yeah. So every day it's going to only be done for 43 seconds. Which one would the customer prefer? So I would say this one is going to be a better one with respect to the uptime, right? So in the entire year, it's only 4 hours. If it was 2.5 nights, it is 1 day itself, 24 hours, more than 24 hours. 1 day, 19 hours or something. So that's a huge difference when it comes to choosing zonal versus regional, the SLA part. Uh, Will this be different based on the region? It's same. Beautiful question, Kumar. It is same. So there's no discrimination between zones. So every region, whether it is US Central or something in Asia part, it's going to be the same thing. And they have made it very clear in this. This is the official documentation which we are referring. Nowhere they mention if it is US Central region, it is going to be this. This is irrespective of which region. All the 24 regions, it's going to be the same thing basically. This is the first thing which is going to decide you whether you have to go with zonal or regional. First of all, the SLA. The second part which I wanted to highlight is the cost part. So if I just go to my pricing calculator, let's look into the price for a zonal cluster versus a regional cluster. Then we'll go to the third point about some maintenance, all those things. What's going to be helpful there? So if I just go to the two ways you can do this thing, just search for Kubernetes, it should get it, or you can just click on the icon there. Now let me just walk you over this. The number of nodes across all the specified cluster. Let me put it as three. Let me put it as three, or yeah, three should be good enough. The number of zonal clusters, number of regional clusters. So I will just mention it as one, and all other things I'm just going to mention it as default. I'm not going to even check it, and I'm just going to do it as default region is US Central. So if it's a 3 node Kubernetes cluster, and if it's a zonal, basically, what is going to be the cost? The cost is going to be 3 times of a virtual machine. So the default machine type is going to be N1 standard. So 72.82 US dollars is the cost. The most important thing in this cost is it is only the cost of the virtual machine, folks. There's nothing extra, no hidden cost. So you see one cost called as cluster management fee, which is 0. This is your master node or your control panel, this thing, it's totally free. So if it's a zonal cluster, this is free. Now if I make it as the same thing 3, but I go with a regional cluster, hit on add to estimate. So maybe I should have given a name. 1 minute, folks. Let me give a name so that I can make it very easy. So what is the purpose? What are the nodes for? Production. This is for production. 1 regional, 3. Add to estimate. So this is my production one. Okay, so this is my production. The upper one is my dev, for example. So $72. Now if I come to my production, the GCE instance cost is same, no difference. But look at this one. There's going to be a cluster management fee. It is $0.01. So per month, if you just do the math, it's going to be what? 730 hours. That's how Google usually does it. 730 hours. So into $0.1, it's going to be $73. So this is the cluster management fee. So when you go with a regional Kubernetes cluster, you get some better benefits. So for that, you have a premium price to pay. So this was 0. First, when Google started in 2015, they had a management fees. In the middle, they dropped it. They made it 0. From last 2020 July, if I'm not wrong, they again started putting this cost, the cluster management fee cost. And if it's regional, if it's zonal, it is 0. If it's regional only, it's going to be, there's a charge. Um, AWS also does the same thing, but Azure does not do this. So Azure, whether it's regional or zonal, there is no cost, is what I heard in one of the, I saw in one of the documentation. So AWS and GCP, there's a cost if it's regional. So it's regional. So you have a cost implication. Keep in mind. So this is the second information which will decide whether you want to go with regional or zonal. The third important thing is if we add multiple masters in the zonal also free, you cannot add. How can you add? You don't get access to the master itself. How can you do it? You cannot do it. So what you can have is multiple zonal Kubernetes cluster, you can do it. But whenever you do zonal, it's going to be the master is going to be already one. So you don't have control there. But when you make regional, it's going to be again 3. So you don't have control how much I want as the master node or the number of masters or the number of control plane. You don't have control there. That is only controlled by either zone or region. That's it. All right. So now let's assume a case. We have a Kubernetes cluster. So if you just search, so the first point was SLA wise, what is the implication? You take a call. The second one, I have given you the price information. You take a call, which one is going to be good for the customer requirement. The third one is cluster gets created. Yes, cluster gets created. And whenever you create a Kubernetes cluster, it comes up with a specific version. It comes up with a specific version. I have selected a stable version. 1.17 is the version. Now, if I just look for the latest version, latest GK8S version, the latest version as of 29th of now January is 1.20. So meaning I'm behind 3 versions. So I'm using 1.17. The latest is 1.20. So there could be some specific vulnerability or some feature which the customer expects to have, and in that case you are forced to upgrade to a newer version. Now if I'm upgrading it right and the customer expects with zero downtime, you should do the upgrade. Everybody expects that. Now if you go with a zonal Kubernetes cluster, what is going to happen is I'm currently using a zonal Kubernetes cluster. It's zonal. This is a version. There's an option for me to upgrade. So upgrade the master version. If I click on this, it's going to allow me to upgrade. Will it going to upgrade? So because I'm using, okay. If I just do this one, static. Okay, static is okay. 1 minute. I have to change it to regular channel. Okay. I have two options. From 17, I can go to 1.18. Usually it's one jump only you can do. From 1.17, you can go to 1.18. From 1.18, you can go to 1.19, 1.19 to 1.20. So one step, one version at a time only you can jump. So I can go to either one of this 1.18 if I were to upgrade. Assume in 1.17 the feature is not available, but in 1.18 Kubernetes it's going to be there. Now when I do this, there's going to be a downtime. Your master is going to go down. Meaning if the master goes down, what is that understanding? Your API server, all those things are going to go down. So if it's a zonal, because it's only one master, you'll definitely have a downtime. But if you go with regional one, right? Anyway, you have three zones, three masters. So this is going to happen one master at a time. So your outage will be almost zero downtime. So whenever you are upgrading all those things, it's preferred to use, basically, if you have plans for upgrading all those things, prefer to use a regional Kubernetes cluster. So this is the 3 points where you should decide whether you should go with a regional one or a zonal one. And there's one very beautiful article created by a Googler called as Sandeep. If you just search for this, it's worth reading this, looking into this YouTube video called as Kubernetes, uh, very nicely described by that Googler. Kubernetes zero downtime deployment upgrade. I recently did this one implementation. So this one, 7 minutes, really worth looking into it. Let me get the copy. I'll just put it in the chat, folks. When you have some time, oh, what a big link. Let me just put this. Uh, this article is awesome. This is an old article, but still worth looking into it. Uh, let me just. Please look into it when you have some time. Very beautiful article there. Uh, I used it. If you use regional Kubernetes cluster, you'll not have any downtime. Uh, and I also tried it on a production system. I had a same requirement. Uh, the version which was deployed was 1.17. There is a sorry 1.16 actually, and the customer wanted some specific requirement which was available only in 1.18 version. So then I had to do this 2 times upgrade from 1.16 to 1.17, from 1.17 to 1.18. And because it was production, I had already deployed it as a regional Kubernetes cluster. And I did this. This was for a US customer 2 weeks back, if I'm not wrong. And I did this during their morning time. So which was my night time. And there was no complaint, folks. It was working. The app was running. So there was no issue there. So that gives a very clear picture. This is going to be really a good option when you're going with production, where you have these three options. Cost, yes, definitely there's an extra cost, but that's going to come with some benefits. Manage your masters basically with zero downtimes. Sorry, upgrade your master with zero downtime, and you will definitely get a better SLA, service level agreement, for availability or for uptime. So that's the reason why you should choose these either of those options, zonal or regional. Since we are doing for a learning purpose, zonal is going to be good for us. The reason is we want to get that free part. Cluster fee, we are going to make it zero. So let me just do this back, something like GKE cluster one. So we selected, what did we select? We selected a specific zone, and you will have all the 73 zones. You can count it. It's going to be 73. So in every zone, you can have a Kubernetes cluster provision. So we selected Singapore A. That's it. Now, the moment you select it, what's going to happen is the master is going to be decided there. So that's where your master is also going to get created. Now, when it comes to the specific version, we see the latest version of Kubernetes is 1.820 as per the search which we did. So it's 1.20. Now, which version you want to deploy is going to be something which you need to get to know based on all the requirements. So there are different options which you can look into. So for that, let me just look into this documentation, the master version. So when I click on this, there are different channels available when it comes to the release versions. Sorry for the flicker, folks. Okay, so you have rapid channel, regular channel, stable channel. So rapid channel is for folks who want to get the latest stuffs as quickly as possible. So if you go with this channel, you are going to get latest features of Kubernetes and you want to try out those things. That's going to be a good option. Regular is where it's 2 to 3 months after releasing it in rapid. And the last one, for you, testing out the new feature is not the concern. You're not working in a project where the customer is expecting some cutting edge technologies. They want something which is more stable, which works bug free, a stable version, a long term support kind of a stuff which you have. That kind of a stuff means you go with a option called as stable channel basically. So that's what you get as those options here. So release, let's just look into that. Release channel, when I go with stable version, let me start with the bottommost one. In the stable version, I have only these versions, folks: 1.15, 1.16, 1.17. Now there were I have seen Kubernetes from 1.10. So 1.10 to 1.14 are deprecated, end of life. So Google is not supporting it. So the stable version is these things. Now, if the customer says there's something in a specific version, can we try it out? If you go with stable, this is what you get. You don't get anything apart from this. So if you want something better, you go with something with a regular one. Regular channel is going to be something like in between. Stability is also going to be there. Some new features also going to be there. So meaning you can go up to 1.18, 1.18 basically. And if you say no, I want something very serious which has been released in 1.19 version, go with rapid channel. Go with rapid channel where you can get up to the latest closest one, 1.17.7. 1.20 is still not there, available in GCP. So it is available in GitHub. If you just go to Kubernetes GitHub page, you should get the latest one, but it's not made available in GCP yet. It's going to come soon, basically. So this is basically what you get in your different channels. So this is your release channel. Now, when I click on my static version, basically I get all the stuffs, static versions basically from everything. So if you want any specific version, you can just go choose it. But this is going to be basically a regular plus stable versions only. The rapid is not going to be there. There's one question from Kumar. Is it possible to change from one zone, from zonal to regional, or do I need to create a new cluster? Very good question. This is during the creation stage. Once you have a Kubernetes cluster which is zonal, you cannot go and change it as a regional Kubernetes cluster. It is not possible. You have to do it. You have to create a new cluster, basically. So that's about the master stuff. What we will do is, I would prefer to use something stable. The only reason why I use stable version is this Kubernetes stuff, folks. You do the same demo today, tomorrow you do something different, it's not going to work. So I don't want to take any risk. I know one specific version which works. To be very frank, yesterday night I tried the latest version, something has broken. So the latest, not that very latest, what I did was I tried something with uh, this one, 1.18. The demo which I used to show, it is not working. That was a very important feature, so it has broken. So maybe they may fix it. So that's the reason I thought, let me not go with something regular or rapid. Let me stick on to stable. So the stable version, I checked, it worked. So that was the reason during the before the break, I went and made it basically a stable version of the Kubernetes version. So prefer which one you want to do basically. So we did this one. So let's leave it like that only. So that's our first part. That's our first part basically. So there are a few other stuffs which we'll go into it. There's one question: is it possible to migrate on-premise Kubernetes to GKE for a easy management? So that's where the concept of Anthos and all is coming into picture basically. If you already have a on-premise open source version of Kubernetes running, what you can do is basically you can use a platform which Google has launched called as uh, Anthos, where you can do those cluster management easily from the same GCP console. So you get those options there. Look into it. You don't need to even migrate it. There are options where if you install certain agents, you can manage the on-prem cluster from your GCP console only. Possibilities are there, Vijay, and that's where Google is heavily investing these days. Anthos, look into that. That's going to help you out. So first screen we have finished. As usual, even in our compute engine, we went screen by screen, right? So let's go into the next part. The next part is, this is the cluster basic stuff. Going to the next part is pools, the node pool details. What are the nodes, how many nodes you want? What should be the configuration of those nodes? All those details is what you need to mention. So the first important thing under the node, and this is the most important thing for us, this is what we can control. The master we cannot control, and we don't even know what is the configuration of that master, the machine type. We will not even get that info, but we can decide what should be our configuration of our worker nodes. So when I click, you will definitely usually get one default node pool. So that's the name. If you want, you can change it to different one. So new clusters will be created with at least one node pool. A node pool is a template of groups of nodes created in this. More node pools can be added or removed after cluster creation. So I can keep on adding more. So let's go with the default name, and you're going to have the Kubernetes version on each node also. This is where that kubelet comes into picture. So what you have decided as your master version, you have to use, it's going to be uh, your node pool version also is going to be the same thing. So in each nodes, the same Kubernetes version is going to be running. The number of nodes minimum is, or default is always 3. So default is always 3. So if you just leave everything as default, it's going to be a 3-node Kubernetes cluster is what you are going to create. So even in our case, it's going to be 3 nodes only. So can I make it 0? No, I can make it only 1. I can have minimum one node running. So meaning one control plane, one node basically. There are a few options where you can restrict the address. So this is slightly, let me make it as 3 back. Pod address range limits the maximum number of cluster. So what is this? We'll talk when we do into our networking part of it. So how many, this is controlled by basically virtual machines going to be created. So inside the virtual machine, you're going to have something called as secondary IPs. So something on networking that's going to decide how many pods you can create and all. So for now, let's leave it as default. The second important thing which you get is enable auto scaling. So if I just do this and mouse over on this, auto scaling dynamically creates and deletes nodes, exactly like what we saw in our virtual machine class. So where you can have minimum, uh, this is slightly which confuses me, how to explore this again. So this one is the maximum number of nodes. This and this little confuses me many times when I do it. So when I turn on auto scaling, right, I can have 0 nodes. It is an acceptable one. Or if you want 1, you can also have it. So what you are basically doing is, if there's the same kind of demo which we did, we put a huge load, stuff start increasing, how much to extend it can go. So this is going to be a maximum. How many VMs you want to create more, auto scaling in feature. So you get this easily built in by just a small checkbox. This is node level auto scaling. So one node you start with 1, maybe something like this is going to be a good choice. Okay, maximum, this is going to be your maximum one. So if I make it as 30, okay, today I got an understanding. So the maximum, this one is indicating the maximum number of nodes, maximum number of nodes. So if I make it, okay, at least 1. So this is the stuff. I got an understanding. So this one, this one, then why should we have 0? Is sometimes this is going to be really helpful. What you do this, if you have this kind of an option, is this is basically for auto scaling. Now assume the same example which we did in our MIG, no traffic, nothing. What you can do is you can scale down to 0, meaning no worker node running on a Sunday or on a Saturday. But when Monday comes, people hit, it's going to scale up to 1 maximum. So you can, and you cannot stop a Kubernetes cluster, folks. Virtual machine, you can stop it. Kubernetes cluster, you cannot stop it. So if it's a powerful cluster, maybe this kind of a combination will help you out to scale down to 0 if there's no traffic. So that's the reason why 0 option is there, Deepak Bhandari. So I hope it's clear. So max is what you can go is 1. If you mention 100, 100. But if there's no traffic, make it 0. Please save my cost. That's it. That's what it is basically doing it. So let me put it as 3 for now. Done. Then specify the node location. Is there a
Hey,
question?
Mahesh. Yeah,
Yeah.
Mahesh, sorry. Uh, I mean, maybe I'm getting pretty confused here. Why we have auto scaling here? Because here we are just still we are using Kubernetes cluster to deploy and run our package, right?
Hmm.
Then when my application is running, whether it's a regional or a zone,
Hmm.
my application my application volume is based on the for example, if it's Monday I have more traffic, there I will use the auto scaling concept. Okay, but
This is
for deploying and running the software, why I need auto scaling?
so this is, as Vijay mentioned, this is a node level scaling. So usually how it happens is, so at the end, this all your pod gets deployed where? Node, right? It gets deployed in a node. So if I just go to the slide back, so it goes back to a node. Now, a node can have what is the configuration? You can have maximum is 96 vCPU, 624 GB of RAM. This is the max you can have. So there's a configuration for every node. So if there's a node, how many parts it can allocate is going to be a limit there. So if you are going with one node, maybe this pod, I can have 10 such pods in one node. But if more load comes, meaning you need to have more pods, only then it can be served, means I need to have a second node, right? So that is where this node auto scaling is required. So this is at a node level. So if you start with one node, that node can support n number of pods. But if it exceeds beyond that, the node is already exhausted. It cannot create more contain pods. So then you have to have a new node. Node provision should be done. So this is node level auto scaling. So is that clear, Kumar?
If you don't mind, can you please repeat once again? Sorry,
Sure.
sorry about that, Manish.
So assume one node Kubernetes cluster, just one node. This is what you will have. And assume, or why don't I do this? Let me just do this. Let me just type this. I usually do this towards the later stage, but now you are asking it. Let me. So now you have, uh, you know what is a pod. So you have one pod uh, which expects some X vCPU and Y memory. This is what is required, a pod, which is going to be basically your container. Now, what you do is you create a 3-node Kubernetes cluster, a 3-node GKE. Now, let me just make it up here. Now, the requirement is you deploy this pod. Now, I have N1, N2, N3. Now, one pod, assume one pod can take 100 requests, RPS. Okay, that's what it can do. So now I just deployed my pod, which is going to have my container and it's going to have an endpoint, all those things. So pod 1 deployed, 100 requests serving. More load comes to my website because it's becoming popular. Maybe the second pod gets created. Now what I am doing is pod auto scaling. The pods are getting scaled. This is basically called as horizontal pod autoscaler. So this is at a pod level I'm doing. So this is happening nicely. Now it is 300 requests coming. So what will happen? Maybe in my, and this one, in which node to get executed, this is going to be totally done, decided by Kubernetes. So you can control it, but it's highly recommended you don't control this. So the third pod gets created in node 1. Still more load, 400 requests coming. The fourth pod, fifth pod, you are continuously getting load. So sixth one. So you are going like this. Now this each node, right, it has a capacity. So each node, each node can, with their capacity, with their machine type, each node can handle or can hold or can serve only 3 pods of that configuration. Because of that machine type, it can only do this. Now still more load comes, your 7th pod gets scaled up and it's going to be in node 1. Next, further load 8. The last one 9. Now still load is coming on the website. Now I don't have any capacity left. What's going to happen is there's going to be a signal sent to the API server saying that we are exhausted, we don't have any nodes. Then what's going to happen is the one which we did now, enabled auto scaling, right? Node level auto scaling is going to turn on. So node level auto scaling is going to turn on, which is going to do basically, yes, let me provision you a 4th node. Let me provision a 4th node. Now my 10th pod is going to get created here. Now, if I had mentioned in my node level auto scaling, minimum is 3, maximum is 6. So this can go up to node 6. Afterwards, I will get service unavailable kind of an error. So this is basically 2 kinds of auto scaling. One at your pod level, HPA, horizontal pod scaling. The other one is your node level auto scaling. Hope this is clear, Kumar. If there's any application along with database multi-set, will it generate more load on the nodes? We'll talk about replica set later, Vijay, because we have not even come to what is a deployment pods. Pod we know. What is a replica set? What is a deployment? We have not discussed it. So once that concept comes, we'll definitely talk about this. Okay. So others will not get it if I start explaining that. So pod auto scaling, is this clear, folks? Pod level and node level. Kumar, is this clear? Still not clear. Okay, clear. So this is your node level scaling. There are 2 more types of scaling which we'll talk later. Vertical pod scaling is also available. So min and max. So it can go up to n node 6. That's it. Afterwards, you cannot do anything further. So basically, something of your MIG is already working behind the scene. I'll show you that also. So let's go back. So in this case, we are putting this. Then you have this.
Excuse me.
Yeah, Vivek.
Node scaling is like provisioning new server. I mean new machine. Na? Node
Yes,
level is
it's a new machine. It's
provisioning a
new
new machine.
machine. New machine.
Yeah.
New machine.
And pod level is
You
like creating new pods inside a node.
existing node. In an existing node.
Okay.
That was a good one. So that it's just in a new. It's a new machine. That's it. So here we are showing us. So here you are showing us node level scaling. So yes, here if I do it, because I'm in a node, right? So if I do this, what this checkbox does is basically a node level scaling capability. So basically that is what I'm showing here. Yes, Anil, that's correct. So that's your node level. Okay, sorry. Node level scaling here is what I'm showing. Pod level, we have to do some configurations. So I'll show you that also at a later point of time. HPA, specify a node region. So this is where your master comes basically. This is additional nodes must be from the same region as additional original zone. Kubernetes allocates more resource for footprints. So this is if you want worker nodes in some other region also, you can do it. So but the master is fixed. The master is fixed in A zone basically, because that's what you have mentioned. So this gives a very clear picture. Now if you want some additional nodes in some other zone, it's okay for you to provision it. For us, let's just leave it as the default one, and you get this option of auto upgrade, auto repair turned on by default. So meaning auto upgrade is from 1.17 version you want to do it, basically, sorry, from 1.17 point something, a minor version, it's going to get automatically upgraded to 1.17 the next minor version. So this, for minor versions, this is going to help you out, so that it's going to be kept up to date. But if you were to do from one major version to another major version, 1.17 to 1.18 is a major version, 1.18 is a major version, that you have to go and explicitly do it, or you can do some automation there, but I would suggest not to do that. So minor version upgrades, it's going to be turned on by this part, basically. And there are surge upgrades, all those things, we'll talk about that at a later point of time, not now. Let's just leave it as default. Now when it comes to nodes inside it, this is where my interview question was answered. So for a Kubernetes cluster, the nodes, what is the OS it's going to use? Container optimized OS. We got that in our compute engine stuff itself. That is the same thing is being extended here. Why? Because it's optimized for running containers, and you also get a container runtime. That was one of the prerequisite, right? The worker nodes or the node pool should have that. So you use this option. Now you get some little other options also. You can use container optimized OS. That's one option. You have container optimized OS with container D. So this is what Vijay was showing, sharing us yesterday. So going forward, this is going to be the recommended one. You see, container D is a recommended container runtime for GKE. This variant uses Docker as the container runtime. So from 1.20, there's going to be some changes happening. So it's not going to be Docker is going to be, it's not going to be your runtime. Container D is going to be your runtime. So uh, you also have options running with Ubuntu. You also have an option to run it on Windows. This is a cool feature. So now you can run containers on all, both Windows and Linux both here. So you get this support, folks. Is this part clear, folks? So by default, it is currently Docker is our container runtime. It may change in the future with the document which Vijay shared yesterday. So for us, that's good enough because we have learned it. The concept is going to remain the same there. So default is container optimized OS, which is going to use Docker as our container runtime. The machine type. What is the machine type? So you can change the machine type, whatever the series which you like, you can go for it. So the same thing which you get as in your virtual machine, you get it here. So you want to use N1 standard, use it. The default currently is E2. So you want to choose, you choose it. What is the stuff? All the stuffs which you have seen in your compute engine, you get it. The preemptive, you can also have preemptible nodes, meaning the three virtual machines which you have provisioned, all are going to be preemptible. If you want, you can turn that also. So, but be very cautious to use preemptible, because if all the three virtual machines are taken back, you will not have anything. So it's going to again provision one. So you are going to have downtime there. So for learning purpose, if you want to reduce the cost, instead of running three regular virtual machines, you run three preemptible virtual machines. You can do this. So all our learnings in our compute engine is going to come into picture here. And the boot disk is not going to be 10 GB, it's going to be 100 GB. So only reason is it's going to have some components of Kubernetes installed, right? So you need more space there. So that is the reason. So this is your basically your node configuration. What kind of machine type, what is the OS you want, all those details you mention it. You have full control here, basically. If you want, if you are running a containerized workload which is compute optimized, go with compute optimized option. Or if it's memory optimized, maybe Redis, which is an in-memory database. So you want to run something in a containerized fashion, you can go with a memory optimized one. So you get all those options in your virtual machines which we leveraged. Coming to security, something which we have seen multiple times, the service account, default access scope. So the same concept. The moment I change it to something else, the access scope is going to be removed, and I'm going to have something with my IAM. shielded VM concept comes into picture. You see the reason why we went through those virtual machine stuffs to a great extent. It becomes so easy going forward. So I'm just going to leave it as default, but you have an option of running your worker nodes in with a different service account altogether. Metadata, there are some metadatas which you can add so that you can access it, all those things. That's your node pool configuration, and you can add n number of node pools as you want. Why do you want n number of node pools? Basically, what I have done in one of my implementations is I decide a node pool. It's going to be it's going to be identical machines only. So 3 machines is what we have mentioned. All 3 is going to be of the same configuration. Basically, the truth is it's behind the scene managed instance group, folks. So you can add n number of node pools. Why? Basically, what you can do is if you have a very powerful Kubernetes cluster, one workload could be general workload. Maybe you just give a default node pool there, general. Maybe there are certain workloads which is little compute intensive. So you can decide all my pods should get deployed only in this specific node pool. Something like I can have a node pool like memory intensive, or and I may go with something which is slightly powerful. I can go with this kind of a stuff. And when I deploy the pod, I can decide in which node pool it should get deployed. So that way my workload gets deployed in the right node pool and uses the right configuration there. So with what would you recommend the service account? So I would always go with custom service account. I'll always go with custom service account. We have decided that very well in our this thing itself, right? In our virtual machine class. If I just go with my Google this thing, the default service account which I get, it's not of no use because it's editor role. So I should always go with the user created service account, Vijay. Can I control my user request to go through a specific node pool? Good question. User request to go, because user request meaning there's an app, that app should serve from this thing is what you're asking, Anil. Is that is your question? Uh, what you can do basically is you have to do this at the you have
Actually, sir,
nodes. Yeah.
actually, Mahesh, I'm talking about we have one Kubernetes cluster, which is the master, right? And
Uh-huh.
there we are
Uh-huh.
attaching multiple node pool, right?
Mhm.
One node pool is having normal
Workload. Yes.
configuration. Another
Yeah.
node pool is more of the memory intensive or compute
Mm.
intensive. If my
Mm.
one of user is looking for high memory intensive, can I route my those calls from Kubernetes cluster to that particular node where we have a memory intensive or compute intensive node pool?
So you are routing the user to that basically uh, the routing you, when you mean it is
So,
a
suppose,
specific
suppose I have one,
application,
yeah, I have one
application in
application.
running
Yeah,
which is
yeah,
memory
I have one
intensive.
application.
So
Yeah,
yeah, go ahead, go ahead.
so I have one same application which is deployed in one node pool, and the same application in another node pool. Suppose user is giving multiple file attachments, suppose, right, which is going to a heavy file attachment. I want that to go to a different node pool. Or
Okay.
maybe if you just let me know the more detail why we need the node pool, multiple node pool, that will suffice. Yeah.
Multiple node pools is basically you have specific workloads which requires a specific configuration. I can just have one. If I have one, right now, where I have default node where this is having a specific configuration, N1 standard T, that's it. I have only 3 machines. Now I assume, let me just go here. So I have 3 nodes, N1, N2, N3. Now I have to deploy basically three applications. So I have containerized it so I can deploy it. Now there is one pod, uh, pod 1, which requires, say for example, some configuration pod 2, pod 3. Now, if I go, and this is one node pool. This is node pool 1. Now, if I deploy this pod 1 here, this pod may work to some extent there. So the configuration may suit here, but I may have this pod which is little memory intensive. So if I run this memory, oh, I'll just mention it as mem. So if I want to run pod 3 in node pool, it may not be efficient there. The reason is it may not work with the fullest potential there, or sometimes what's going to happen is the pod itself will not get deployed, because when I create a pod, I can mention my CPU and vCPU and memory limits. I can mention how much memory I need, how much this thing I need. If I have mentioned slightly high, this node pool may not even fulfill that requirement. It's going to show pod cannot be deployed. So in that case, going with a dedicated node pools for a specific kind of a workload is going to help you out there. So you can control what kind of machine, what kind of pod should run in what kind of node pools. That's a basic purpose of having multiple node pools. And you can decide this pod should get deployed in this specific node pool. But inside the node pool, in which node, that you will not be able to decide. But which node pool you have to decide, you can decide that in the configuration, Anil.
Yeah, got it. Got it.
Yeah.
Yeah, thank you.
Yes, Vijay, to some great extent, you can control basically your vCPU and memory stuffs. I'll show you that. How can you do it at a pod level? I want 0.1 core, 0.1 vCPU, 200 MB of memory. I can mention that. And that is going to decide in which pod I can, which node pool it can deploy. So C group
Node pool, it is not
namespace.
a C group.
No. So
Node
that
pool,
is
it
the
is not a C group. Okay.
no. So namespace and C groups is what Google used to call in the beginning. So it's not that. Now,
Okay. So node pool is not a C group, right?
no, it's no.
Okay.
Okay, I deleted my default node pool. It's okay. Anyway, I'm not going to provision this VM. So that's our node pool configuration. Now, when it comes to cluster, there are some more features which we can do. Some automation, basically. About the maintenance window. When do you want to do maintenance? So the auto upgrades, all those things, right? You can do some stuffs there. There are some options where you can mention based on your stuffs, what is your kind of load coming on your system, what could be the quiet period you want to try that. You can do that kind of maintenance window configuration there. And there are few features of notifications and all which you can turn on basically. And you get two more kinds of scaling, which is vertical pod scaling. If I just turn this on, what is going to happen is if that pod needs more vCPU and memory, so automatically analyzes the container CPU and adjusts this. So it's going to increase the vCPU and memory for the pod to work perfectly there. So meaning it's going to run in the same node. But if the node is not having enough capacity, then it will have an issue. So this is vertical pod scaling, the opposite of your horizontal pod scaling. Another option which you get is basically called as node auto provisioning. So here what happens is without this is a newer version there. So where if you want a new node pool to be configured totally on the fly, you can do this kind of a stuff where you can do this. A node auto provisioning manages a set of node pools on users behalf, meaning you started with one node pool, but looking at the load kind of a stuff, it looks like a new node pool itself should be created. So in that case, you can go with node auto provisioning. Okay, so the auto scaling which we do here is within a node pool you create more VMs. But when you have this automation turned on, where is that? Where's that? Okay, so here, sorry, where am I lost? Sorry, here. So when I turn on this node auto provisioning, I can have more node pools configured. In very simple terms, folks, node pool maps to a managed instance group. I'll show you that demonstration. So vertical scaling is making the same pod more powerful so that it can handle the load better. So if you just mouse over here, it analyzes your containers, CPU and memory and adjusts it basically there. So it's going to give more to the existing pod itself, make it more powerful. Instead of having a new pod, make the same pod powerful so that it can handle 200 requests basically. That's where your vertical pod scaling comes into picture. I don't usually prefer this option. Horizontal pod scaling is going to be much better, but these are the options which you get here. Then you have the configuration or the option of having your servers account, all those things. Networking is an important stuff where you can basically create two types of cluster. By default, it's always a public cluster. What do you mean by a public cluster? The the worker nodes will have an external IP address, and your master can be reachable from anywhere easily. If you have the right uh, private key, you should be able to get it. The other option which you always do is a private Kubernetes cluster. Private Kubernetes cluster is preferred one in production because we don't want the worker nodes to have external IP address. External IP address is going to be more trouble making stuffs because when you expose yourself, you will definitely have issues. Instead of that, go with virtual machines, which is internal IP address. So that's where you're going to use private Kubernetes cluster. This is the preferred way in production. And we'll talk about more about internal IP, external networking class. Maybe at that time we can try to create one. I'm just going to put a small implementation tip. Prefer to have prefer private GKE cluster in production. Basically, that's something, but the default is always public cluster, meaning the virtual machine, the worker nodes will have an external IP address, and you will also have an external endpoint to your master node, the control plane where you can access your API servers, all those things. Coming to, and there are a few other options which you get.
Excuse me.
Yeah, is there a question? Yeah, Vivek.
I am a bit confused. You told us that master is not exposed to public users. Means how it can
The
be
API. Okay, let me just show you this. I have one cluster already, right? Let me just show you that. That's going to give a better idea. So if I just go to Kubernetes cluster, before the break, we had provision one. It's an empty cluster, which is running there. So this is the cluster. So when I click on this cluster, I will have some details. Now this is my endpoint. Now I have to connect to this Kubernetes cluster, right? So I have to get those certificate and all. So this is my master endpoint, where once I get access to this master endpoint, the API server, which is hosted in the master, I can communicate with my Kubernetes cluster. So if I make a public Kubernetes cluster, I'm going to have a public endpoint like this. And I will have the worker nodes or the node pools all with external IP address. So because it is a 3-node Kubernetes cluster, this is what you will see basically. You will see all external IP address. This is what happens if you create a public cluster. If you go with a private cluster, if you uncheck this also, everything is going to be private. The worker, the master's external IP through which you can access the API server, that's the heart. That is also going to have an internal IP only, Vivek. Make sense?
Okay.
Yeah. So that's on the the networking part. So you have few other capabilities there. The maximum number of pods which you can run in a node, what's the maximum you can do is 110 pods is what you can run. This is basically controlled by, again, networking. So we'll talk more about in networking class, what is /24, what is /28 as a subnetwork mask, all those things. For now, let's just leave all the things as default under networking. Coming to security part, you have few security features. Few of them could be in beta. If you want to turn on certain stuffs, you can turn on those things. So shielded GKE is something which you can do. Binary authorization is a feature where you can check whether you can put some kind of a policy there. Do a check whether the container image, because there's chance that somebody can have a vulnerability embedded in a container image, build it, push it to GCR, and that gets deployed into Kubernetes. This can happen, right? So you can have this check so that you can check whether the image is valid, whether it's using all the binaries, which is valid, uh, which is not having any vulnerabilities. To do that kind of a check, you can turn on this binary authorization. So basically like a signed jar. So usually you can, if you install any software, it's going to show it's signed by, it's from authorized source. That is the same thing which you are going to get this with binary authorization. And there are some few new features called as confidential GKE, which is going to basically use your AMD processors, basically the confidential VMs. The same concept is going to apply here, and few RBAC rules, which is in beta. Let's not look into it. Cloud identity is another important stuff. So sorry, workload identity. So this is going to be basically how your worker nodes or your node pools can communicate with other Google APIs. So more again on IAM. If possible, I'll try to show you some demonstration next week on this part. This is a newly added feature. Newly added feature. The last part is basically on metadata, which is basically the description. So as a part of your knowledge transfer, it's good better you put some description to your Kubernetes cluster. And the last one is features, where you're going to get some features which you can turn on. Cloud Run for Anthos. We are not looked into Anthos. We are not looked into Cloud Run. At that time, I can show you what is this going to be basically. So for now, let's just leave it. And you can turn on logging. This is very, very important. And by default, it's going to be turned on. The logging is going to be turned on, which is going to help you out to get some statistic information. There are other few features. You can turn on TPUs. You can have worker nodes, or the nodes have GPUs, CPUs, vCPUs. You can also have TPUs, which is Google's specific processing unit, tensor processing unit. You can have that. And there are a few other capabilities which you can turn on. Istio, currently it is in beta. So if I just turn on, what is going to happen is the Istio related components are going to be added to your Kubernetes cluster, basically. And there is one interesting feature which you can use, which we may talk at a later point, GKE usage metering. So you want to find which, usually in an organization, they will create a very powerful Kubernetes cluster, and they will create something called as namespace. So one team, one namespace. Now what you can do is you want to know which sub-business unit is using most of the CPU, most of the utilizing more. You can do this metering option, GKE metering, where you are going to get information per namespace. So per namespace. Now namespace, you can treat it as you have an apartment. Each floor is one namespace. Now if you want to know in each floor who is spending more electricity, you want to know that kind of a stuff. That kind of a metering, you can get it easily with this feature turned on. There was a question. Sorry, what was that? Somebody unmuted themselves. Was there a question there? Okay. Sorry, I forgot about the break. Okay, sorry. So that was all the stuffs, folks, about the cluster. Now if you click on the command line, you'll get an equivalent of it, a very big command line, worth slowly looking into it at a later point of time. So if you click on create, it's going to create a cluster. Since we have already created a cluster, I'm not going to click on create. I'm just going to leave it as it, but the cluster is ready. So what we will do is we'll just take a 5 minutes break, folks. Take a break and come back, and the cluster is ready. Now it's the remaining part is going to be like a cakewalk. So just deploy your workload and see how it gets deployed. Okay, so let's take a break. Hope 5 minutes is okay, folks. Otherwise, I'll run short of time. So 5 minutes. I did not see the time. So take a 5 minutes break, a bio break, come back, then we should be able to resume back.
This conference will now be recorded.
So before the break, we saw the entire container creation stuff, meaning step 4 is done by us. And what we saw, one more thing which I explained you via by just typing it, was this one, folks. Auto scaling in GKE. So more pods is going to be for your workload related stuff, is going to be your pods. And you can also have a pod increase, vertical pod scaling. And when it comes to the infra part, you add more nodes, the current node only, but you add more nodes. But if you want to increase more node pools, you are going to use node auto provisioning stuffs. So one is at a workload level, one is at a infra level. So this is something which we talk. So because you asked the question, so before I wanted to show the slide, I answered it there. So now let's go back and do the remaining part. Step 5, 6, 7, and 8. Maybe 2 or 3 steps we will do it, and we'll stop it for the day. Now let's go to this thing. We have a 3-node Kubernetes cluster. So this 3 indicates how many VMs are there basically. If you just go to your virtual machine, and you should see 3. So if I just go there, I'll see 3, and some hidden secrets I wanted to share about this Kubernetes cluster. So what are those things? Let me just show you. So go to dashboard. Because I see 3 nodes in my virtual machine, I should also see 3 nodes only. 3 nodes only, and each node you will see a name called as GKE. This is to indicate that this is created by your Kubernetes cluster. And because it was a zonal Kubernetes cluster, all are going to be in the same zone. And because it was a public Kubernetes cluster, all the VMs are going to have a public IP address. But the most important thing in this view, what is that, folks? Names okay, zone okay, external IP okay. What else does it attract you in this screen apart from those things, folks? What is that one thing which grabs your attention in this screen? Any specific column which grabs your attention, folks? In use by. Yes. In use by. Yes, Anil Kumar. Yes, Kumar. That's correct. So basically, it is nothing but a instance group, folks. So it's this, whenever you see this option, it should hint you that it is an instance group. So it could be managed or unmanaged. That you can go and look into the details. So if I just go into my instance groups, I will have one instance group, one node pool, one instance group. And you can see the node pool details there here. GKE is the prefix which is always going to be there, followed by your cluster name, followed by your node pool name, and some randomness there. That's it. So it's a 3-node, it's a managed instance group where they have mentioned basically 3 virtual machines. It's managed. Now, for an managed instance group, what is important, folks? For a managed, how do I create a managed instance group? What is the most important thing for a managed instance group? Any thoughts, folks? What's important? No. As how do I create a managed instance group? A image should be there, a template should be there, right? Then who created the template? So who created the template? So minimum and max, definitely it's going to be there. So if I just look into it, maybe auto scaling is not turned on here. So if I just click on edit, so there's no auto scaling turned on in this one because I did not turn, I just left it as default. So auto scaling is not turned on here. But for a instance group to get created, there should be a template. So if you just go into the template, you'll come to know something better. So it's basically MIG. Yes, it's basically a managed instance group, and there's a template created by the Kubernetes for us. So no need of template, no need of MIG or the custom image creation. Everything is created by Google for us. Now this is where you see the first slide in our compute class comes handy. When you create Kubernetes or container as a service, virtual machines, everything gets abstracted. You don't need to focus on creating a template, a custom image, creating an instance group. You focus on creating a cluster and focus on deploying a workload. Now, one small hidden fact, if you just go inside this, if you have some time, go look into it, you will see some good amount of startup scripts and all, folks. You'll see lots of configurations. If you have some time, go explore it. So what and all gets provisioned in each virtual machine, you have those things as some kind of a startup script. If you have time, totally out of topic, but you can see how it's been done. Basically you get an idea there. So very good stuff. Explore it if you have some time. So this you can get it in your startup script, sorry, in your templates for your Kubernetes cluster which you have created. So template is there, image is there, instance group gets created. You just need to deploy it. That's it. You just need to deploy it. So the time we spent to learn our managed instance group is not in vain. It is continued. It is continued in the more modern workloads, the modern compute options, which is Kubernetes. Kubernetes is a modern way of deploying your stuffs. For that, the base is a managed instance group, which was a virtual machine based on virtual machine. And virtual machines are old school. You see the stuff there. You see the connectivity there. So what we spent was really worthful is what I wanted to indicate here. Now, this is an empty cluster, folks. I cannot stop the cluster. So empty cluster is of no use. So you have to deploy some workloads. So to deploy the workload, click on your workload, deploy a containerized application. I have not deployed anything except there are some system level workloads which is going to be running. So if you want to see those system level workloads, you can see it. This is basically to control the Kubernetes cluster or the system level. So where we see kube proxy, all those things, stuffs which we saw, it's going to be there. These are system stuffs, but I don't have any user based workload. So it's an empty cluster is what I would say. So if I just go back to workload, there's nothing. Now, how do I deploy it? Simple. The trick is either go with this option or go back to your container GCR, folks. Let's use the same functionality which we have learned. So to deploy a container on a virtual machine, we started from GCR, right? Let's do the same thing here so that our understanding is going to be the same thing and the same approach. Go to your GCR, go choose the latest image. Instead of deploying it on GCE, we have gone up the ladder now. Deploy it on GKE. We tried this one. Let's try the second one. Cloud Run, we'll see it in next week. Now, when I click on this, it now comes to my Kubernetes screen, folks. Is this clear, folks? What I'm doing? Is this clear? Just wanted to make this very clear. Just let me know whether it's clear, folks. So we wanted to deploy a workload on our Kubernetes cluster because our cluster is currently empty clusters of no use. So we want to deploy our containerized workload. So one option which we are trying to do is by going to the container registry and leveraging the second option, deploy to GKE. We will see deploy to Cloud Run later. So deploy to GKE. GCE is already understood. Now when I click on deploy to GKE, it should come to my Kubernetes engine screen. Done. It selects that version very specifically. This is what you want. Yes, this is what I wanted to deploy. Go ahead. So click on done. Then click on continue. Then it says a deployment is a configuration that defines how Kubernetes deploys, manages, and scales your container image. Kubernetes will ensure that your system matches this configuration. So by default, it gives a name. It is not Nginx. So I'm going to call this as hello demo. That's it. That's my application name. And the namespace is going to be by default. You can create multiple namespaces. As I mentioned, this is going to be like each floors in your apartment. If you're living in an apartment. So one namespace, one for one team. So by default, if you have not created anything, everything is going to get deployed in a default namespace. You have a labels which you can create. So usually what name you give, that's going to be your app name. That's it. Then the most powerful thing in Kubernetes is doing everything in a declarative fashion. Now we are doing it in the UI, but the UI is very smart. It generates us a YAML file. Deployments are defined declaratively using YAML. The best practice is to store these files in a version control so that you can track the changes to your deployment configuration over time. They themselves, like reading some of those tips itself will give us an idea how you should do. So if I just click on this view YAML, this is a YAML file which is generated for us by Google automatically. And they are recommending this kind of configuration should be kept in a version control system like GitHub, Bitbucket, Subversion. Google also has a specific product inbuilt called as Cloud Source Repository. Next week we'll explore that. So this is basically a declarative option, meaning I give everything in a declaration. I need to deploy a specific image and I want how many copies? How many copies I want? I want 3 copies of the same pod. And what is the kind of object it is? It is a deployment. We will have different we will have n number of objects in GKE. One of the object which we are exploring now is a deployment object. And when you do this from the UI, right, you will get an capability which is going to be automatic called as auto scaling. This is your horizontal pod autoscaler object. What is the kind of object here? HPA. The above object which you saw was basically a deployment. So here it does a built-in configuration like if there's no CPU utilization, nobody hitting your website, it's going to turn on to minimum 1 replica. Number of pods you can have maximum is 5 pods. If there's no request, it's going to scale down to 1 in the next 5 minutes, basically. So that's what it's going to happen. This is a capability of your horizontal pod scaling. And the metrics which I'm going to use here is CPU. This is automatically generated when you do it in the UI. But when you do it in the command line, which we will see in our next class, you have to explicitly turn on HPA. Let me just stop here, folks. There are 2 kinds of objects which is generated by the UI. It's not we who generated it. We just gave a name to our deployment and it created a YAML file for us automatically. And it also created one more object, which is HPA. That's it. All good. Now this one, where do you want to deploy? This container, where do you want to deploy? You can either create a new cluster or you can use your existing cluster. We have an existing cluster. Let's go ahead and deploy it. So when I click on deploy, my container is going to get deployed. Which one is recommended? command line. Command line is recommended, but I cannot directly jump into command line because it's not going to make you comfortable. So that's the reason the same demo is going to be repeated in command line in next week. And that too, two styles in doing in command line. UI is not the best way for Kubernetes. Command line is always the best way. Done. I have my deployment done with the name which I gave. Hello demo. Good. Now it gives me some recommendation here. To let others access your deployment, expose it to create a service. Let me just follow it what it is. So let me expose it, meaning I'm exposing my service there, the welcome to containerization tab. So when I click on that expose, it tells me two different stuffs. Port mapping. So if I just mouse over on this, the port on which the service will accept traffic. So how I'm going to access this service? 80 port. If I just mouse over on this port, target port, the port that container accepts traffic and where the service should route the traffic to. When use when the container accepts traffic on a different port than the service. So my container accepts traffic on which port, folks? What's the port on which our container accepts the traffic? 8080. Look into your Docker file. Look into your Docker file. That's going to give you the idea. Expose. What was mentioned in our expose command? So if I just go there, what we had mentioned was 8080. So that's where our container listens on. So you have to give that as your target port. So let me just show you that. By the time that comes, that's it. Just gave the port details. That was the mandatory thing. If I don't mention it, it's going to be 80 and it's not going to work for me because my container is on port 80. Why it is slow? Okay, I'll show you this thing. Hope you recollect the configuration. Yeah, it came up. So if I just go to my cloud architect, container, cat, docker. This is the line which tells me on which port my container is going to listen, port 8080. So that is what I have to mention. But I wanted to access it as an end user on port 80 is what I'm mentioning here. So the type of service, how you want to expose it. Do you want to expose it to the external world? You can use load balancer. If you want to use it internally, you're going to use something called as cluster IP. We'll talk about all those things later, folks. So these are different ways of exposing your service. Node port, individual virtual machines which is there, you can access it via the individual virtual machines also. So there are three different ways, actually four different ways. One more is called as ingress. We'll talk again more on that. So because I wanted you to access it, I'm going to go with something called as load balancer. So what this basically creates is, it creates a network load balancer behind the scene. So where I can see it, so in our MIG demo, if you remember, we created a L7 load balancer, layer 7, the application layer. Now, when I want to expose a service quickly in Kubernetes, it's going to create me a network load balancer automatically for me. I don't need to go to the networking section, create my load balancer. You currently see nothing is there. But the moment I click on expose, it's going to create me a load balancer. Basically, this is a regional load balancer. As usual, when whatever you do in Kubernetes, there's going to be a YAML file. Now, in the first time when we deployed a workload, we got a deployment kind of object. We got a HPA kind of object. Now you're creating a service. Now I'm going to get a kind of object which I'm going to get as service, where I'm saying I want to have a load balancer. I want to listen on port 80, but my container is going to accept traffic on port 8080. That's it. So let's just expose it. The moment I click on expose and go and jump into my network load balancer screen, you will see a new network load balancer getting provision. Now, meaning the same 2.5 hours of demo which we did in our MIG, it's not yet there. Let me just refresh it. The 2 hours or 2.5 hours we spent creating a custom image, a template, an instance group, then a load balancer. All those things are packaged here in Kubernetes. I only create my container, just deploy it and expose it. Everything comes automatically. My focus is not more towards networking or anything. So focus is more towards deploying the app. That's it. You see, there's a new load balancer created. There's a new load balancer created. Let me see whether it is up. Yeah, it is up. So it should take few minutes for it to show this as green. Healthy. 3 instances. Health check is going on. So let's wait for that health check to happen. Health check is happening. Because it's a load balancer, I will have an endpoint, folks. I'll have an endpoint. If I just click on it, it's going to show me welcome to containerization. That's it. So the same thing which you did via virtual machine, opening firewall rules, all those things, it became like a piece of cake for us here. We just deployed it, exposed it as a service. That's it. So easy. And we are not focusing much towards the infra there. So that's where infrastructure as a service and a container as a service comes into picture. So container as a service is more easy. I just have my container. If I have my container, remaining everything, it becomes so easy. So let me just stop here for any questions, folks. Let me stop here for any questions. I'll not do anything further. We have 10 minutes. So if there's any question on what we did now, more backends we'll talk about it.
Manish,
So on, yeah.
how do we monitor this? Actually, in on-premise, we are using Prometheus and Aqua Security third-party tool. So here it's inbuilt. If you use a GKE, we can use inbuilt monitoring and security.
Yeah, you get basically a stack driver, which is an inbuilt security module. Inbuilt monitoring stuff which you can get. And with respect to the security part, you can use cloud identity, workload identity. You get your IAM, all those things. So you don't need to have anything third party. Everything is going to be inbuilt.
Okay, so the monitor will
Stack
show
driver,
the
stack
width
driver,
of the content.
stack driver monitoring, or now it is called as cloud operations. You get that inbuilt. You get that built in.
Oh, in the same console?
Same console. So same console, if I just go here, you see this monitoring, it's already showing you the stuffs built in. So what's my CPU, what's my utilization? It's showing me the details right away here without me doing anything. It's built in.
This is the stack driver monitor.
Stack driver, if you wanted to see explicitly, you can go to your cloud operations. Now it's called as cloud operations. Here, if you just go here, it's going to capture everything and it's going to show you. I wanted to keep this as is now because it's going to create certain stuffs behind the scene. I don't want that. But if you want, you can just go into monitoring and you should see Kubernetes cluster stuff, and the entry is going to be there, and you should be able to see the stuffs what you're seeing. This is basically stack driver monitoring stuff only, given easily in our specific dashboard. If you want to go into stack driver or cloud operations, you can go there also. This is an easier option. So this is an easier
Okay.
option. There is one more question from Kumar. Can we see more details on the back end? On the load balancer, Kumar, is what you're asking? Okay, so let me just refresh this. The back end is going to be something here different. So this is a network load balancer. So it's not going to be exactly like your what we had seen, but I'll just click on this to show you the stuff. So edit. And since this is network load balancer, layer 4, you'll have a backend configuration, which is basically instances which you add. So you will not have host and path rules. That's only available in layer 7 because the layer is high, so you'll have more information to capture there. But when you come down the layer, you'll not have that kind of an info. So host and path rules are not there, but you will have a front end where you can configure your protocol and your IPs there. That's it. So this is what is your backend going to be basically. So if you want to create this is basically a TCP load balancer. So the one which we created was an HTTP or HTTPS load balancer when we created it. So this is your backend, and these are nothing but your virtual machines, basically. So I hope that answers your question, Kumar. So what we did basically was, if I just go back to my screen, created a Kubernetes cluster, deployed a container as a workload to our GKE cluster, exposed the application to a service. Good, we exposed it. Last two things, I don't want to do it now because it's going to be an overkill. I'll just going to stop it here to answer any questions.
So Mangesh here.
Yeah.
Yeah. So when the cluster is created with 3 nodes, right? The VMs were created automatically, right?
Yes. That's where your node pool, you mentioned your node pool configuration, right? Node pool is
Yeah.
your VMs, which you got created. Node pool is nothing but MIG, folks. That's your MIG. So the master, you cannot see it, but there's going to be an endpoint which you can access it, basically.
Okay. Thank you.
Yeah. So there's one question, flow, user, service, Kubernetes cluster, node pool application. Is this right? So the flow is going to be something like this. If the end user is trying to access it, so it's going to be end user. He's going to access the service which you have, and the service is going to go directly to your node pools. The cluster will not come into picture in between here. So it's going to directly go to your node pools, basically. And we deployed everything. If when we were deploying it, it was showing 3 replicas, if I'm not wrong, right? Now, if I just go look into my deployment, so this is my service, go to my workload, look into my deployment. So there are three pods. These are the pods. We'll talk more about the pods and explore more on this in our next class. So if you just leave it for some more time, right, what's going to happen is basically it will scale down to 1 after 5 minutes. The reason is there is a auto scaling capability which we have done, the HPA, which was mentioned in that declarative option. Minimum 1 replica, maximum 5 replica, CPU utilization is 80. So if I just leave it for 5 more minutes, it's going to go to basically 1 instance. So it's still not there. It's still not there. Let me check what was the time I created it. Just wanted to show you this part, and then we'll stop it. Let me just go to my, and the command line way of doing it is something which we'll explore more. That's the best way, but I just wanted to give you a small comfort zone by doing something in the UI first time. If I directly start with the UI command line, you'll not get it. Ignore the command which I'm doing. I'll explain you this in tomorrow next class. So if I just do kubectl, this is the utility which you are going to use to connect to your cluster and do anything. So 14 minutes, it should have scaled down. Why did it not scale down? 14 minutes is the age. Okay. So basically that auto scaling, right? What does it mean basically is Aman. So if there's no load, minimum keep it 1. If there's more load, it can go up to 5. So that's what it mentions below. So when it is underutilized, it will scale down to 1 basically. Yes. So it should have scaled down because the cluster was, sorry, the stuffs was created uh, basically 14 minutes back. Okay, this is something which happens. So this is
Mice
okay.
actually, if any example, if any e-commerce application is there, right? So that time, if some sales or something happen, that time it'll get a high load. So that time only that auto scaling, um, will increase the certainly will, increase the load. After the sales
Correct.
finished, auto date will reduce. So
Correct.
that's so that
That's
auto scaling purpose.
Yeah, that is the main purpose. That's the main purpose. So you have more load, and so you have three copies. You have three copies of your hello or welcome to containerization this thing. So it's going to serve. If more request comes, it can go up to 5. It can go up to 5. Afterwards, it cannot go, because that's the limit which you have put. So this is at a pod level scaling you are doing. So that is the reason why I showed you this one. At a workload level, you have two different options: horizontal pod scaling and vertical. But when it comes to the infra part, more nodes are required, then you are going to have the node level or the cluster level scaling, or you can have node auto provisioning options. So we'll stop it here. We'll stop it here. More on Kubernetes. It should have worked actually. It should have scaled down to 1. It should have scaled down to 1. Looks like there's a specific issue with this version.
Mice, one
So
question.
yeah, 1 minute, 1 minute, 1 minute. So when I do this one, this command, right? Currently it shows there's no traffic to my this thing. So unknown is it showing. At least it should show 0 or something. So when it shows 0, the maximum replicas will come to basically, sorry, the replicas will come to 1. Currently I'm having 3 pods running. So it should have actually scaled down to 1 as per the configuration, but it's not doing. I'll check that. Maybe I see some issue basically with this kind of version, specific versions of Kubernetes, it's having issues. I'll check it. Go ahead, Vijay. Okay, before that, let's stop the class. 1 minute, 1 minute. Before this, let's stop this class, the stuffs. If you have a hard stop, you can log off, folks. And if you have questions, I'm happy to answer one by one. Go ahead, Vijay.
Since the GUI is more comfortable, right? So that it automatically generates YAML file everything. So go for CLI.
And maybe next week when I show you, you will become more comfortable. Uh, Forget about UI. In the terminal also, you can generate the YAML file very easily. There are some options. There are some tools. Uh, there are some tools. And there was one question: is there any UI to generate Docker file? Per my understanding, I don't know one. But Packer, which I mentioned yesterday, can help you out. Somebody asked that question. So yes, GCP, learning GKE in Kubernetes in GCP is going to be a little easier, is what I would say. So there are a couple of more questions. Can you spend 1 minute on the previous slide of this thing? So yes. So here, when you have a workload, basically, and it needs to scale 1 pod, 2 pod, 3 pod, 4 pods, 5 pods. This is basically our horizontal pod scaling, HPA. This is based on your workload. Similarly, if you don't want to add more pods, but the same pod, you will have some memory utilization. So you make the pod more powerful so that it can handle more load. That is your vertical pod autoscaler. Now, pods runs where? It runs on an infra. Where it is that's your virtual machines. Now how many pods you can run is always controlled by your infrastructure. So how much the infrastructure can scale, for that you have two options where you can have a existing node pool can auto scale to some number. That's your first option. If you want more node pools, you already have one node pool. If you want more node pools, you go with node auto provisioning. Hope that makes sense, Anil. Infrastructure scaling while creating cluster and the HPA. Okay, you can do this. Okay, when you're provisioning the cluster, you make sure you turn on. You can turn on these two features at any point of time. At any point of time. This one you turn it using your deployment file. So you can turn on at any
So
point of time. So there's no restriction. You can turn it
yeah,
even after the cluster is created.
so what I understand, cluster creation is not by developer, right? By us, and it must be by someone more from the infrastructure, right? Because
Okay,
if
you are
it
saying
most of the time, yeah,
from the infra team, from the infra team, yeah.
okay, okay.
But
Thank
they
you, sir.
can turn on this
Thank you.
feature in the beginning and also later also. They can do that.
Okay, okay, got it. So we can do later also. Okay,
Yeah.
okay,
Now this one, right? This is the cluster which I have. We did not do anything, so we did not do auto scaling for the node. I can go and check it. So if I click on nodes, click on edit, default zone. Okay, here. This is the node pool. You see node pool, auto scaling is turned off. You want to edit it, just click on this node pool. That specific node pool you wanted to do auto scaling. Click on edit, turn on it. That's it. You can do
okay.
it.
And these
There's
are
no
at the
problem.
these are at the cluster level. So infrastructure auto
Correct.
scaling at the cluster level, and those in the application level,
Yes.
right?
HPA and VPA is at your
Code level.
workload level, at your, yeah. And this is at your
Okay.
infra.
Yeah.
Correct.
Yeah. Thank you.
Always start at your workload, then go to your infra. Directly don't go to your infra, basically.
Okay.
Any other questions, folks? Hope I did not miss one. Can you please show on the auto scaling? Definitely, Kumar, I'll show you. I was planning to show you that with this demo only. It should have scaled down. It did not scale down. Pod level, it did not do actually. I'll check it out. It should have come to 1 actually. So it's not working. I'll check it out, Kumar. So next week when we start, I will do it via command line. When I do it right, I'll show you that part. So after 5 minutes, what happens? If I put load, how it scales up. All those things like what we saw in our virtual machine auto scaling, right? The same thing we are going to see it here. Sure, folks. Sure. Sure, Vijay, you can log off if you don't have. Yeah. Any questions you can log off. Any last few minutes questions, folks? Happy to answer you.
I have
Okay.
one, but that is not related to this topic. But after the
Okay.
uh,
Let me just wait. Let me just see if there's anybody having today's questions on today's topic. Let's give them that priority. Otherwise, Vivek, you can go. Any questions on today's topic, folks? Uh, is it okay? Just 5 minutes overview on the next week class. We'll definitely do it. So we'll definitely do it. So the same concept, we are going to do it again, Kumar, in command line next week. So again, you are going to create a cluster, all those things. So it's going to become an overview automatically. But I'll just definitely give you a quick overview of what we did last week, and we'll just do that. I'll do that. Any other questions, folks? Go ahead, Vivek. I don't think so. Others have any questions on today's topic? Go ahead. If something comes, please put it. I'll definitely answer it. Go ahead, Vivek. You have anything?
actually, Mahesh, I'm trying to install virtual box on my laptop to
Uh-huh.
try some native features of native Kubernetes actually. But
Uh-huh.
my OS version is Windows 10 Home Basic.
Mm, mm,
So that is not allowing just because of there is a limitation. You cannot enable virtualization on Home Basic, some kind of. So
mm.
is there anyone who has tried enabling or any workaround or something? Because blogs are suggesting you should go with a pro version of Windows 10. So
Okay.
just
Okay. So what you want to use Minikube is what you're trying to do, if I'm not wrong.
yeah, Minikube and one. I also want to try one because I have some installation in production in my environment, but I don't get too much exposure to work upon production. So I want to install a 1+1 cluster at least Apart from Minikube is the prerequisite, but I want to install 1+1 minimum cluster with one minimum setup actually.
So you are seeing my screen, right? You can use Cloud Shell. Cloud Shell comes with Minikube. So if you just search for Anthos Sandbox, So this one is going to create a Minikube for you. So just use your Cloud Shell itself. You don't need to install anything on your laptop. Just use this article, and you can have a Minikube running in minutes. And you can have everything stuffs which you want to try on Kubernetes here also for free.
Okay, but actually I want to try on bare metal. We do have some bare metal
On
Kubernetes.
bare metal, your laptop can you so
It's Windows 10 Home Basic actually. It's not allowing
home
me
edition,
to. Yeah,
Windows Home Edition. Oh, okay. Could be a virtual box. Yeah, I have a professional edition of it. I remember this problem, but not sure. I upgraded myself to professional one only because of this one once.
actually
Uh,
I wanted to upgrade, but I thought that I should ask from the guys. Maybe they have encountered similar problem. Might be they can help some sandbox or some any like that's actually. I have an interview actually on bare metal Kubernetes actually. I want to
mm,
prepare for that. So I'm not
okay.
getting moment and sandbox. The only option is that I should go with the pro edition. That's the only option till now I got
To be
actually.
very
Either
frank, right? To be very
yeah,
frank, if you also go with Pro Edition, right, it's not going to be on a bare metal. Bare metal, this one which you're trying to do is not a type 1 hypervisor, it's a type 2 hypervisor. You're not going to get the complete experience there. I would say you better go with Cloud Shell because if you were to do it on bare metal, you have to be in a data center and you should have got access to it. So that's going to be the best way because what you are saying, Kubernetes on bare metals, it's on type 1 hypervisor. What you are going to install on your laptop, the virtual box, is a type 2 hypervisor. So I would
but at least
say,
I will get an exposure to install at least 1+1 minimum set of configuration on type 2 hypervisor if I go with the pro edition.
that you, if you want that, you do it on a virtual machine itself, right? Why do you want to upgrade your this thing, account, your laptop and spend some money there? Use your Cloud Shell itself or use on a virtual machine. That's also fine, right?
I mean,
Because
what
anyway, you cannot use type 2. You cannot use type 1 because you are not in a data center. So you have to
hmm,
use only type 2 means your virtual compute engine itself is going to help. Your Cloud Shell is going to help you out.
okay. You are saying that I should provision compute engine and I try to install.
No, you
Yeah,
can install on a virtual machine also. You can install Minikube. But if you do it, you are going to spend some. You are going to exhaust your credit. Try with this one. This is a beautiful option.
actually I have a
Free.
lots of credit and last 2 days is remaining with my account actually. So I can.
Cloud Shell is free. Cloud Shell is free, Mia, Vivek. Even if
Okay.
your trial ends, it is still going to be there. So that's
Okay.
the beauty of Cloud Shell. You can use it.
Okay. I
Try
think
it.
I can try on as per discussion I came to know that I can try this thing on compute engine also maybe. No?
Yeah. You can do it. You can do it on Compute Engine also.
Okay. Thank you. Thank you.
Yeah. Any other questions, folks? All right. All right, folks. If there's no more questions, we'll stop it here. I'll share the recordings and the updated slide. Uh, we'll resume back on next Saturday. All right. Thank you. Bye.
I think Mahesh, I think there will be 2 more session of compute engine, no? Like app engine and cloud function.
Not too many are going to be there. So we are going to spend good amount of our time on compute related part. That's the most important thing.
Okay.
Cloud Run, Cloud Functions, App Engine, in App Engine 2 flavors, and we have one more session required for Kubernetes itself. So we are going to have good amount of time to be spent yet on compute itself.
Okay. Thank you. Bye.
Bye. All right, folks. Thank you.
Thank you.